Hello and welcome again to this course. In this course, what we are learning is a skill set at a time, a skill that is required, that is mandatory for you to learn and to become a successful either data analyst or business analyst or any kind of analyst. So those skills are extremely important in this particular module, and in this particular course, what we are focusing on is the Python. This is a complete Python course. My name is Ashok Kumar Sharma and I'm working as a senior data analyst or senior data scientist at Cedar Sinai Medical Center. The purpose of this course is to learn Python from start to end. Like you will learn the basics of Pythons, you will learn what kind of libraries you need to use, including from the installation of those libraries to go to a little bit of the deeper like data cleaning, data manipulation, advanced data analytics, and the data visualization. So we'll cover each and everything in this course, and by the end of this course you will able to apply the Python skills to any kind of analytics that you want. So this is the overall purpose of this course. At the end you will get this guide, you will get these slides and complete video for this Python course. So in this Python course, let's go step by step what we are going to cover. So first, who this course is for. So this course is like super basic. I will try to cover each and everything so that anyone who is transitioning or who is coming to the field of business analytics, data analytics, they can get started with. Or anyone who is transitioning, whether they are from the CS background or they are not, or non-CS background, anyone or the students, immigrants, freshers can learn these skills and apply those skills to become an analyst. What we will learn in this section, so like I have divided this into the multiple modules, and those modules I will cover multiple topics. So like the first thing, the very first thing we'll learn is the setup. So setup is like installation of the Python or the Jupyter notebook, or start using your Google Drive and the Colab. So setup, so you will have the environment where you can write your first Python code. Then in the second module, we'll come to the data pre-processing. In this data pre-processing, we will explore each and everything. We will explore data cleaning, data manipulation, everything we'll learn here. Then the third is the data exploratory data analysis. In another module, we'll learn how to do the EDAs like principal component analysis, initial histograms, and all those things to learn and know more about the data. Then we'll learn about the advanced data analytics. In the advanced data analytics, we'll try to learn each and everything that is required: correlation, regressions, additional analysis, and then we'll come to the data visualization part. In this visualization part, again we will learn C1, Matplotlib, different type of libraries, even the Plotly, if we want to build the interactive visualization plots also. And then at last we'll come to the machine learning basics. So this course is completely designed in this order, and we'll have one module for each segment at the end. But briefly, let's see what we are going to get in each and every module. So let's say we are talking about the module 5.1, which is getting started with Python. So in this, we'll learn how to install Python, like either use the Anaconda or use Pip or use Minicon, whatever environment you would like. Then how to set up your Jupyter notebook environment. And from this Jupyter notebook, you can have your own environment where you can load the libraries, where you can install the libraries, and you can start writing your first code. Then we'll learn in this particular module, we'll learn about the basic Python syntax, like what is variable, what are the loops, types, these kind of things we'll learn. Then we will utilize the Jupyter very effectively, like importing, exporting the data. We'll learn in the next module also. And then demonstration, like loading your first data set. So this will be all about the first module, like your environment is set. You can load the first data set that you would like to analyze, and you can write your first syntax in that particular environment. So this is all about module 5.1. Okay, now the module 2, 5.2, in which like we'll do importing and exploring the data. So in this, like we'll learn how to load different kind of data sets, like be it CSV, Excel, or JSON file, or the image file, different kind of images file, how to load them, how to inspect the data, like doing the head command, describe command, info command, to learn more about like how many columns are there, how many rows are there, how many variables are there, what kind of metadata information you can use for the additional analysis, how many variables you should consider, how many variables you should delete or remove from your analysis. So those kind of things we'll learn, like identifying the missing values, converting the values from the categorical to numerical if needed, from numerical to categorical if needed. So those kind of conversations or cleaning basics, everything we'll learn in this section, in which when we are saying importing and exploring, like we'll learn not only about loading the data but identifying the features of the valuable feature which we can move forward with, and like all the data cleaning manipulation type of stuff. We can load one data set here, like we can load one demo data set. It can be Titanic or tips data set, and we'll do the same thing that we have discussed here. Okay, after this, in the third module we'll come like go a little bit deeper, and this will be all about the data cleaning and data pre-processing. So data cleaning and pre-processing, we'll learn a lot of new concepts. We'll learn how to handle the missing data, like we'll do the drop NA function. Do we need to remove the variable? Do we need to fill or impute the variable? So those things we need to decide. So here there will be a lot of concepts that we'll learn, like at what circumstances you will remove the variable and will not consider in your analysis. In what circumstances you will not remove the variable, but you will use some kind of imputation to use it in your analysis. So those kind of things we'll learn. Then like how to detect the outlier in your datasets, how to clean, how to remove those outliers. Then we'll learn about the data encoding, label, one hot, these kind of techniques. Like these kind of techniques are very very important when you are dealing with the data. Now you are trying to create a kind of regression model, for instance, but the data or the variable you are using, it has some of the categorical values. So you need to convert those categorical values into the numerical values, or in sometimes if you have a numerical data and you want to divide into multiple groups for the binary classification or multi-class classification, then you need to do the data encoding. You need to divide those values into the certain categories that you can use for the comparisons. So those kind of things we'll learn. Then we'll learn about date parsing, feature extraction. Then the most important part is the scaling, finding out the min max standards, how to use these information to normalize and scale the data. This is very very important. When we are comparing two groups or three groups, you need to normalize for the efficient comparison, you know. And the last, we'll use any kind of demonstration dataset, Netflix churn dataset, we can use Titanic, tips, any of the dataset. After the data cleaning and data pre-processing, we'll come to the module 5.4, that is the statistics in Python. It's the most important module, and we'll learn a little bit of the concepts about like key statistics, what is mean, what is median, what is mode, those kind of things, and then standard deviation. Then we'll learn about the correlation matrix, why it is important. Then after correlation matrix, we'll learn about the hypothesis testing, like t-test, chi-square test. We'll learn parametric, non-parametric, which kind of test we need to apply in what circumstances, in what conditions. So those things are very very important. Then we'll learn about the confidence intervals. That is also very very important to decide the outliers and all those things. And then last, we'll go for the group wise test, gender wise stripping, and all those things. So those kind of statistics that we have discussed here, we will discuss each and everything in detail. We'll learn about the p-values, we'll learn about the accuracies, MC, like sensitivity, specificities, MCC, how to compute. We'll learn about the confusion metrics. When you are doing this test, when you are learning the machine learning based models, how to get the true positives, how to get the false positive, how to get the true negative and false negatives, those kind of things we'll learn here. Then we'll go to the advanced data analytics. In the advanced data analytics, we'll do little bit deeper level of the statistical analysis apart from the one that we have discussed. Then we'll use the group by operations in the pandas. We'll learn this thing. Then we'll do multivariate analysis, like when you have multiple variables in a data set, how to handle that. Then we'll go for the correlation and statistical test. We can demonstrate it using one of the data doing the group by analysis. We can consider any of the demonstration data set here. Last, we'll come to the module 5.6, that is a data visualization module. That's very very important to decide, because when you do all sort of data analysis, when you retrieve the data, clean the data, analyze the data, at the end what you are going to present to the stakeholders, to team members, to the group members, to the customers, consumers, anywhere, you are going to present a plot, and that plot should tell the complete story behind that data, like from where the data was taken, what kind of normalization, filtering you have applied, what kind of analysis you have done, and what are your final interpretation, what are your final insights. And that is the data visualization. So if you are messing up with the data visualization, that means your whole analysis, whole efforts you have done from start to end are going to waste. So deciding the right visualization technique for your data is the most important aspect. So for the visualization, you can use the matplotlib, C1 libraries. We learn where to use which libraries. Then there are different type of plots like bar plots, box plots, histograms, scatter plot, when to use, when scatter plot when you are showing some relationship between two variables, histograms when you're checking the distribution in certain way, like in the group way. The bar plots and box plot provide you different information. Then heat map, pair plot, byline plots. There are different kind of plot that you can use to convey the insights, to convey the masses from the data to the audience. Here you can customize the title, lead gens, everything. Optional, we will learn here the plotly apart from the seaborn and plotlib. So plotly gives you like flexibility, or like streamlit we can learn. Plotly gives you the flexibility to create the interactive plots, not the static plots. We'll learn about these things in detail. Then we'll go to the module 5.7, and that's also a very, very important module. We'll learn a little bit about the machine learning. So in the machine learning, we'll cover like supervised machine learning, unsupervised machine learning, what is a train test split, how to do the model evaluation, how to do the cross validation. We'll learn about the linear regression and the decision trees. We'll learn most important that we have discussed in the statistics also, like how to get the accuracy, confusion matrix, ROC curve. Based on the ROC values or AUC values, how you decide which model is performing better on the cross validation and the test data set. Confusion matrix is very, very important to read, like how to read the true positive, false positive, true negative, false negatives, how to use them to compute different kind of measures like sensitivity, specificity, and all those things. We'll use the demonstration of predictive data sets or the total bill or size data set here. Now in last, what we'll do in this course is we'll select a project, we'll do the churn or sales analysis, and we'll do like complete walkthrough from start to end. We'll take the data, we'll clean it, we'll analyze it, visualize it, we'll create a model interpretation, and we'll show our findings. So this will be our complete project that you can post on your GitHub if you are getting a big real data set. You can take the data sets from anywhere like Kaggle or any other sources. We'll discuss about that in the land. But this kind of walkthrough you can do on a simple project and put it. So if you will do these things, if you learn from this much from start to end, and at last if you'll take a data set and follow these steps and push this project on your GitHub, then I think you know how to use Python. You know each and every basic how to use Python to analyze the data and to present meaningful insights from those kind of data sets. So by the end of this course, I hope you will be ready, and you will have at the end, you will have all the tools. You will have Python, Jupyters, you will have all the libraries installed, and you will have information about all the libraries, which libraries to use at what time, and you will learn about the optional libraries like plotlies and how to post those projects on the GitHub. This makes this course is unique in lot of ways. Like first is the real world experience you will get. You will learn everything from the scratch, like setting up your environment. Okay, you will learn all the skills libraries which are required, which is essential for the beginners or the career switchers to become a job ready analyst. No need to jump between the multiple tutorials. Here you will get everything from start to end, the complete Python course. You will have the recorded live classes and the PPTs and PDFs. So let's begin. Your data analysis or business analysis journey starts from here. Let's start working on the module 5.1 or module 1, where we'll start setting up the Python environment. Thank you. See you in the next video. Hello and welcome everyone. In this, like, we are going to discuss the module 5.1 of Python, in which like getting started with the Python is the main objective. Like to set up your environment, to set up you with everything, like whether you will use the Jupyter notebook or the Google Colab. So what we are going to cover in this module specifically is first like installation of the Python, either using Anaconda or Miniconda or using pip, setting up your Jupyter notebook. Then we'll learn basic Python syntax. We'll learn about the variables, types, loops, and everything. Then using Jupyter effectively, like either use Jupyter or the Google Colab like notebook. And then we'll go to the demonstration, like load your first data set. So in this, we'll cover the basic things. So by the end of this course, I hope that you will be ready to set up your own environment, and you will able to write your first line of code in any of the system that you are any of the OS that you are working. So let's start with the doc. In this doc, I have written everything, like from where to get started. So in this, the first thing we'll do is the part 1, and that is the environment setup. So for the environment setup, we can either use the Anaconda, as I discussed, we can use the Miniconda, we can use pip or BS. So let's start first with the Anaconda. So this Anaconda includes Python, includes Jupyter notebook, and the packages management all in once. Like if you will install the Anaconda, you will get everything, all the resources at the one time. So for this, installing the Anaconda, what you can do is you can go to http www.anaconda.com.download. From here you can directly load the Anaconda here, and in the Anaconda you can either go to the free download either go to the free download here, or you can do the sign. In this you will get most of the libraries. It's open source, user friendly, and super trusted. You can get all the libraries for data exploration, visualization, AI, machine learning, natural language processing, GUI, and front end development. These are the main libraries that you find here. Any other libraries that you want to use, you can use. To download it, you can use the Conda, or you can go to the mini Conda installer. From here you can download the mini Conda installer. You can directly go here, mini Conda installer. In the mini Conda installer, you can download it for the Mac, or you can go for the Windows, or you can go for the Mac, or you can go for the Linux. Okay. Once you will download the mini Conda installer, I am not doing just the downloads, again and again, because I have already downloaded it. But feel free to do it if you haven't. If you will allow it, it will download. You will see here. It's downloading the complete package, mini Conda package for you. Okay. After this download and everything, your environment, your specifically the mini Conda or Conda environment is ready, that you can use for, say this, that you can use for any of your operations, like downloading the Python, installing the Python from here. Okay, so in this, like, I'm just clearing the window, you can use Conda install whatever you want to install here. Okay, after installing the mini Conda setup. Okay, now the second part here is, if you're not going by the Anaconda or mini Conda route, if you just want to install Python. Okay, if you just want to install Python and pip for all the packages, then you can go to the www.python.org, then downloads. Okay, here you can simply go to the downloads. You can download the Python for macOS directly, or you can decide which version you want to download. Okay, releases, their versions 3.14, 3.12, 3.2. From here you can directly install the Python. Once you will get the Python, you can check the Python version. You can, right now I think I have Python 3.9, so you can do Python 3. Whatever version you have, Python, and then you will do what. So in this we have right now Python 3.9.2. you can get the pip also, and you have pip version. So right now I have pip 20.24.0. Now using this pip, you can install any of the libraries. So why we are installing Python? To set up our Jupyter notebook environment. So for that, what you can do is simply you can go to pip install notebook. I will not hit the run button here because I have already everything installed. Once you will do this, you will get the Jupyter notebook installed. How to check this? You can simply type Jupyter notebook in your terminal. Okay, once you will type the Jupyter notebook in your terminal, you will get to the notebook. Let's say this is your environment where you're getting everything. In this, like, you can select any of the folder where you want to work, and you can create the new notebook. You can open the existing notebook, you can open the terminal, you can open the console, you can create the folders, file, whatever you want. Let's say I'm creating the new notebook. I can create the name of this notebook, which can be test, and all set. I'm good to go. In this notebook, I can start typing, I can start writing my first code, I can start writing whatever I want. Okay, from here you can define whether these columns you want to use. So this is your, right now this is for the code. You can see here this is code. So in code, let's say you can go to the print, let's say, and you can simply type in your, here you can just start typing. Okay, print hello Python. You can define from here, like next code library is the markdown for you. So in the markdown, this is not a code, you can write whatever you want. Here is my first Python code, write it here, markdown, and then you can write your code in the code section. This is your markdown, this is your code section. Here how you can decide. Now if you don't want to install the Jupyter notebook, if you don't want to install the Python, Anaconda, anything, then you have the another option. In the another option, what you can do, you can go to your drive. Okay, in the drive you can go to the new. In the new you can go to the more, and more you will see here Google Collaborate. But this is not true for all the cases. If you have not installed the Collaborate, you will not see this option. So what you can do connect to more apps. We'll click here, and from connect to more apps, might take some time. Yes, here you can do the search, and in search you can do Collaborate. Okay, Collaborate. In the Collaboratory, I'm not getting the install option here. In the another tutorial and another apps you are seeing there are install option, because I have already installed it. You will see the install option here. You can click on that and you will get it installed. Once it is installed, you will see the same kind of option. You will see in the more, you will see the Google Collaboratory. In the Collaboratory, again, you will do the same. Whatever we are doing in Jupyter Notebook, exactly the same thing you can do here. So the Colab will be open. It is again also taking a little bit of time. Once the Colab is open, you will do the same thing. exactly same thing that you were doing in the Jupyter notebook. And what you will do here is just name this Colab whatever you want, like test, and you can just write print hello py. Now from here you can decide whether this is your code and what you want to write. When this is your code, you can just write the notes also. This is my first, this is my first Python code. Okay, that's how you can define where you want to write code, and this will work exactly in the same way. You can just keep adding the code wherever you want to write. You can just drag and drop where you want to get the code up and down. So the both Jupyter notebook and the Colab will work in the same fashion. Okay, now I hope your Google Colab is set up, your Jupyter notebook is set up, and you are ready to go to the Python crash course in a little bit more detail. In the Python crash course, here we'll learn basic things, very basic things. Now, once you have installed everything, you have Python environment ready, you have Jupyter notebook, Colab is ready. So what do you want to do? Now you want to learn some syntax, you don't want to learn some basics. So these basics are very, very important. First is the Python syntax and variables. What is Python syntax and variables? Syntax, like you need to know what kind of data type it is there, whether you are using the syntax which is a string, which is integer, which is a float, which is a boolean operator like true or false. So these are the things which you need to learn. So now I will just show you in the Jupyter notebook. Okay, in the Jupyter notebook, if you remember, I have this code part here and I'm writing this. So I'm defining name Ashok, age 30, is student is equal to true. I can print the name, age, and is student, whether it is true or false. Okay, if I will hit the run button, I will get Ashok 30 and true. This is my information that is stored. Now you can change whatever you want here, but it's important to learn the storing the information, whether this is a string, variable, whatever it is, how to store that information and how to print that information. Okay, now here the most important thing for you to learn is the basic data type. Integers, which are simple numbers, floats, which are some decimal points along with the numbers, decimal numbers, string, which is a string in which it can be any name, it can be hello, it can be name or anything. Boolean operator will define like whether the thing that you are incorporating is true or false. Then you will have a list and tuples. List and tuple, the only difference is one is mutable, another is unmutable. They are ordered numbers which you can provide. Okay, and then is a dictionary. In the dictionary you can provide a key and value. So this is also important for providing the key and value pairs. So now for instance, if I'm providing this information all the way from, let's say I'm providing, not going to the Colab, I'm going to the same repository where we were working on. So here I'm providing x is equal to 10, y is equal to 3.5, name is equal to Python, numbers is 1 to 3, person is name, Ashok, and age. So this is my dictionary in which I have a key, name, and value Ashok, key, age, and value 30. If I will hit run button, so this information is stored now. Now, if I would like to know the data type, simple. So let's say if I will use one at a time, if I will use the data type, and in the data type, let's say I am first printing only one. If I'm printing print type numbers, so numbers, what I have. So this is a simple list. So what I will get in the return is a list. Print type, if I will do X, is type is integer. If I will do print type by, is the type is float. Okay. Print type, if I will do name, that is string. So this is a very, very important thing for us to know, like to know the data type, to know what kind of data and data types we have in the data sets is very, very important for the downstream analysis. So this is the first thing that we do. The second is, let's say if I'm doing print person name. So in this dictionary, I have the name is the key and value is Ashok. If I will do print person name, so I will get the Ashok. If I will do print person age, so I will get the 30. So this is what I can change. I can make this dictionary as long as possible, and from this dictionary I can pull out the information that I want. This is very, 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 very important. Then the second part, the first part is the Python syntax and variables. The second part is basic data types. The third most important part right now is the control flow. In the control flow, there are some functions, and those functions are very, very important. Those are if loop, those are while loop, those are for loop, and there are if, while, for, and other type of loops. Those comes in the control flow. So if we'll see simple if else example, if else example is very, very simple. If we are doing the marks less, okay, it will simply go, and if we are defining here, if we are doing marks, so marks is equal to 85. If we are doing if statement, if marks is greater than 90, grade A, If marks is greater than 75, grade B. If marks is greater than else, grade C. So what we'll get, the answer should be, if we are doing simple, if it's, we'll get the grade. Okay. If we can change the marks here, if I will change the marks 75, what I should get? Again grade B, because it's equal to or greater than 75. But what if I will do mark 70? If I will do mark 70, then I will get the grade C. So this is a simple if loop, and if loop provide you the information to pass the information from the multiple conditions, and will give you the answer that matches to that condition exactly. Okay. After the if, there is a for loop. In the for loop, you can do the iterations. So for instance, here I am doing an iteration for I range in 5, print iteration $I, print each number. So 5 numbers, the range I'm providing the number of 5, 0, 1, 2, 3, 4, and iterations will print all those numbers. I can do these iterations to 50, I can do these iterations to as many as I want. So for loop is good when you want to iterate something, you want to print something again and again. Okay. Now there is very important, which is a while loop. And in while loop, you can do a condition. Let's say if I'm doing a while loop, in the while loop, I can do n is equal to 3, check if n is greater than 0, print that number, and then do -1, and then go back again and repeat this till this condition is true. So if I will do this, I will print 3, 2, and 1. And I can do this like to n number time. I will do 30, then 30, 29, 28. It will keep doing. So while loop is also good for putting a condition where you are putting a number, you are giving a condition, you are giving a countdown, and you are putting any information there like minus or plus, and keep doing that till, like, you can do this information for the plus also till the number reaches to the certain point. So any of the condition that you can play. Okay. So this is all about while loop. Then there is a function. Function is like very important part here. You can define a function at a time. The good part of function is when you need to do the things iteratively, then the function is a good part where you can define at a time, and then you can call that function multiple times whenever you need it. So I will show you some examples also. Let's say if I am doing, this is my function right now. So my function is right now, define greet is my function, define greet name. So return, what will be the return after this? Hello name. So if this is my function, and if function is stored here, and if I'm calling this function print greet Ashok, so what it will do? So if I'm doing print greet Ashok, it will return me. There is something wrong with this. Got it. So what was wrong? Did you check that? Because I didn't call that function at the time. If I call the function now greet, it will print the name hello and the name. If I'm calling the function greet, it will calling me hello Ashok in return. So this function is extremely important when you're calling something again and again. Okay. Now if I'm calling the function, anything I can call here, this function will return me the same information. Now, if you simply see what we have learned here, we have learned the Python syntax variables, we have learned the basic data types, we have learned the control flows, if else, loop and while loop, and the function. Now you can do the simple practice. You can create the list of 5 numbers. You can write a loop to print their squares and define the functions to calculate the average. Can you do this? So let's say if I have these numbers, okay, if I have these numbers and if I am doing the square sums. So if I will go to here again, and if I have these numbers, this is my list. So numbers are stored. Can I check nums? So nums are stored. Okay, 2, 4, 6, 8, 10. These are my numbers. If I will do 4 for n in nums, for each n, print n square 2. So n square, what I will get the results is 2 to the square 4, 4 to the square 16, 6 to the square 36, 64, and 100. This is the information that I will get. Okay. Now I can change it. I can do the cubes for each number and I will get this. I can change the list whatever I want. Like if I can do this 20, what I should get now average. So it's 20, 24, 30, 38, and 48. 48 divided by 5. So it will, I will get some like 48 divided by 5, something like for the function. Oh, I'm not computing the average. Okay, sorry. So this is the triple. Then if I will compute the average of these numbers, how will I will do that? So for computing the average, let's say I will create a function. The function is how to calculate the average. Tell me, simple. If I am calculating the average, so the average will be of this. What will be the average? 2, 4, 6, 8, and 10. So the average will be 6, 6, 12, 20, and 30 divided by 5. So will be 6. So how to use the function for this part? I am doing define average values, sum the values, divide by the length of the values. Simple. Like sum these values 2, 4, 6, 8, 10, and then divide by length of the values, which is 5. So this 30 divided by 5 will be 6. So if I have this function and now the function is ready, now I can call this function for any value pair. If I will do print average, average nums. So if I will do this, print average, now average is my function. So by average function on nums, if I will calculate, I will get the average of 6. Now I can change this number, anything that I want. I will do 20, I will do 40, 60, 80 and 100. If I will do this, simply it will be the average now come will be the 60, because I am now calling the average function only. And whenever the numbers will change, the average will change. Now the good part of this function is I have defined this function only one time. Now I can call this function multiple times for different values, for different keys. Anytime I can call it. So functions are usually useful when you need to do the process iteratively, very iteratively. So in the end, what you learned how to install Python, Anaconda, Miniconda, Jupyter, Pip. Then you learn how to work with the Jupyter notebook or the Colab. Then you learn basic Python codes, variables, loops, functions, everything. So the purpose of this module was overall to set up your environment so you are ready to write your first line of code. So this module is overall complete. If you have the environment installed, if you have everything set, then it will be easier for you to follow the module 2. So I hope you will get ready with this, and see you in the next video. Hello and welcome again into module 5.2 of this Python course. In this, we will briefly discuss and we'll briefly learn how to import and explore different kind of datasets. We'll learn different kind of like CSV file, Excel file, JSON file, image file, or directly from the link, how we can import and load the data, and then we can start exploring. So this is very important topic to learn, as so far you have learned like how to get started, how to set up your environment, how to start working with the Jupyter notebook or with the Google Colab. Now when your environment is set up, almost all libraries are installed, you can start with importing the datasets either from the online resources or from the already saved data files in the CSV or Excel format. In this, mainly we will learn like how to load CSV, Excel file, JSON file, or any other file formats directly from the databases. Then we will, after learning this, then we'll little bit do like inspection of the data that we will load, like using the head command, describe command, and then we'll identify the missing values. Specifically here we are going to use either the Titanic or tips dataset. Mainly I have took the demonstration of the code using the tips dataset. So I hope you guys are ready for this module now. The main topics will be the reading and writing of the CSV file, reading and writing of the Excel files, basic SQL integration like read and write tables directly used in the Python, then the fetching the data from the API using the request. If the request library is not installed, you can install it using the pip install command. I will show it to you, and then hands-on the example dataset. We'll meanwhile, after loading the data, we'll do the quick exploration of the data, including the identifying of the missing values or the identifying how the data looks like in terms of number of columns, tables, number of columns, rows, what kind of data is it like integers or the float, what kind of variables and values are there. So part one is the reading and writing from the CSV file. I hope you guys know what CSV file is. CSV file is simple comma separated value file that are most common format for most of the dataset. It's simple, lightweight, and easy to handle using the Pandas libraries. Okay, I can show it to you. The dataset that we will work is it's a tips dataset. If you will see here, CSV file can be anything like this. This is the data. If you can simply save it in the format of the CSV, you will get directly the file. So like I have saved here tips.csv data. It will look like this. Simple CSV file, comma separated, and easy file to load. Now, if we will go to the data set and we'll start working on it. So let me open the file. Okay. So now when we are working on the importing and exporting of the data, the first thing you need to do is the import pandas at a PD. Now, if you don't have the pandas function, so in that case, you need to install it. So you will do pip install pandas. Okay. This command you need to run. Once you will run this command, you will have the pandas installed. Then you can do the import pandas as a PD. And now using the pd.read.csv, you can read this file. Now if I will read this file and simply do data.head, I will get few lines of this data file. So if I will do run command, see. So this is my data file. How it's look like, it has a serial number in the rows. It has some columns, total bills, tips, sex, smokers, day, time, size, This is the file, like I have certain number of columns and few rows. We know this is our data, then how to move forward with this? CSV file can be loaded like this very simply. Now you have already seen the first 5 rows of the data set. Now you can load this file. I'm just making a copy. Now if you want to, let's say, save back into the drive where you are working, so if you want to save this data file, you can simply go df dot to csv, and now what we are doing is tips copy.csv and indexing is equal to false. Whenever we will do indexing is equal to false, that means indexing is equal to false means we are preventing the pandas to writing the row number as an extra column, because we already have the rows. If you will do this command, it will save this file, this data file, whatever you have here, into the another file, that will be tips.copy. I just don't want to save it because I already have it. Okay, now it saved the tips.copy.csv for you as well. So csv file is very simple to load. You simply need to do pd.read.csv and the file name. If you need to provide the directory from where you want to load it, you can provide the location and then the file name. Right now this file for me is in my current working directory, so that's why I have directly loaded. Now this is a csv file. Now you can directly load the csv file also directly from the data if you have from the source. So this is a command for that. You can try this. So if you have the link for the dataset, you can get the URL directly and you can load pd.read.csv and you can read this file directly from the URL. I'm not running it. You guys can give it a try. Okay. Apart from loading from the URL of the file, then there are so CSV file, what you can do, you can either do the read CSV or you can directly load from the URL. Now how to read and write the Excel files? So for that, first you need to have the Excel file. So in the Excel file is little not simple as the CSV file, because in Excel file you can have the multiple sheets and you can even write the sheets and you can even read the sheets from the existing CSV files. For this, the command lines for you is the read Excel and to Excel file. These are your commands. Okay, you need to install open py-excel file. You can do this pip install open py-excel and then you need to use this command. Okay, so once you will do this, if I will go here, let me completely copy this command, and if you will go here, the first you will do pip install open py-excel. I will not do this because I have already installed it. Now the data file which we have, we are just saving it into the tip data.xls file now, and we'll give the sheet name as a sheet1. Once we save this file, okay, so now so that data is now saved as a tips data.xls. We can see it also here. If I have saved it into my user work here, this is like little less, so you can see tips data.xls. This is just now saved. Now when you will save this, you can recall it and you can load it back. For saving, you are doing data to Excel, and for reading, you will do pd dot read Excel. And now you are reading from tip.data.xls, and here you need to define the sheet name if you have multiple sheets in a single Excel file. If you will do this, so you can read the Excel file. Now the data is same. Here you are loading the CSV file, and here you are loading the Excel file. And in the Excel file, you are defining the sheet if you have a different sheets for that. Very simple, like as a CSV file. Okay. Now, after doing this, you can simply check again doing the head or whatever data format you were doing. I have already done the Excel data.head to check how many columns and how many rows, or to check the data format using the initial few lines. Now, the third type of data can be reading, writing from the SQL data. And this is a very important. In the Python, you can connect the SQLite, you can connect MySQL, you can connect the PostgreSQL to transfer the data directly. And for this, you need to use SQLite function. So you can use the import SQLite 3. Now for this, you need to install it first. For installation, again, the thing is pip install. Once it is installed, pip install SQLite3. I'm not going to install it, so I'm just uncommenting it. You can just do simple import SQLite. Okay, once you imported it SQLite, then you can do this thing, create in memory database, and then we'll read first, write and then read. Okay, why we are writing? Because we have data already stored. So now in this, what we are doing is creating the in memory database using the SQLite. Once in memory database is created, Then we'll write the data file in the tips table, and we will replace if existing database is already available. Once we will write this, then we can read it back. I will show you the read back command. So first we will write. So it is telling us like it is written, and why we are getting 244, like we have a 244 instances or 244 row in the data. Now we can read it back. So for read it back, we can, for SQL, we can do the command like select from tip table, because we have saved it in the tips table. Okay. So from the tips table, where what we are getting, the total will is greater than 20. So like from the all data we have, so if I will see here, what we have is data, and in all data we have like total 244 rows and 7 columns. In this I'm saying just give me the rows where the tip is greater than 20. So not for the all data sets. So here I can do, or like the total bill is greater than 20 from the con. Okay, so I can do this thing, and if I will do this, see, I have filtered my data by just getting the instances where the total bill is greater than 20. I'm just seeing couple of lines by doing the head command. I can do little bit more. I can read the complete data also. If I will do the SQL data complete, not head, then I will get total 97 rows. Like out of 240, 97 instances are there where total bill is greater than 20. So this is the power. Like you can use the SQLite, and using the SQLite, you can read, write, filter, and do your SQL commands directly in the Python environment. Okay. Now you have already seen it's too easy to query the data directly in the Python, and the real world projects like definitely using the PostgreSQL, MySQL, using the Python libraries, you can use it. Now, part 4 is fetching data directly from the APIs. Okay, this is very important. APIs can let you access the live web data, stock prices, weather, COVID stat, etc. Anything that data is like changing in the real time. So you can provide the website link and fetch the data from there. For that, you need to load or install the library called requests. For this, again, you need to do pip install requests. Okay, so I will go to the code section. You go to the code section. I will do the pip install. I will not run this command, but I will do the import requests. Once I load the library, then I will go to the another part. I will use the code example. Let's use the free sample API that return the JCS as a fake user data. So we'll get the URL, we'll get the responses, we'll print it, and then we'll convert it into the data frame. How to do it? Simply, let's put it like this. So this is a URL, JSON placeholder, typical code, users name, URL. From the URL, I will record the responses, and these responses I can print. Before converting it into JSON file or in the data frame, I will do simple print. Now there is a error with the URL code. So yes, why we are getting the error? Because this is not a command line. Okay, not with the URL code, but error we were getting because this we need to comment it out, because this is simply a comment, not a command. If we'll do this, now it is loading the data from the placeholder, and the status code, they are giving the status code for us. Now from the status code, we can convert it response JSON file into the users, and then we can print the, so these are the user file, but is not in the CSV format, or this file not in the data frame format where we can read, we can analyze, we can inspect. So to convert this, we'll use pd.dataframe, and now we will convert the users into DFU. And here we can check the head command again, how the data look like. We'll convert into the data format, so we'll see something like this. We have names, we have username, we have email address, we have their addresses, phone numbers, websites, and the company name where they work. And we can definitely, we don't know right now, we are just looking at the top 5 rows, but we can definitely do and look at how many users we have in total. I think we have total 9 to 10 users only in this particular data set. Okay, so this is the easy way. Give the link, take the responses, check the status, convert those responses in JSON into the users. Let's say you can give any variable name here, and then the usernames, and then the users can be converted into the data frame. And now this data frame can be explored in the same way we explored the CSV file, we explored the Excel file. This data can be explored in the exactly in the same way. Okay, now we can do little bit of the further inspection. So far what you have seen for the data, you have seen head command. Head command will, what will do, it will print out top 5 rows. Then we have the info. What info does? Info will provide you all the information about the variables. Like if we are dealing with the data is the tips data, so we are getting how many columns we have, in each column how many instances we have, how many non-null counts we have, how much data type it is there, like float, object, or integer, what kind of data types are there. So we'll get this kind of information, like data types we have float, integer, and object, and memory uses. Okay, apart from this we can do a lot of other things also. We have already got like non-null values are there, but if we would like to inspect the missing values separately, we can definitely check the missing values. There are n number of ways of checking the missing values. I have written few of the commands for you. You can keep it exploring whatever you want. So like here are some of the data type that I'm doing. Let's say we can do simply, we can do print data is dot na. Is there any na available? False. There is no na. Missing values are not available in this. Okay, we can do like another commands. We can do print data is dot null. Is dot null is also one of the, it's also false. So you can do is dot na or is dot null to check if there is any missing values or not. Okay, you can do count missing values per column. You can do count total missing values per data frame. You can do view rows which has any rows with the missing values. Check the non-missing values, how many non-missing values are in the data. You can keep running this. You can keep inspecting the data sets. You will find out all the information about this data. So now, in summary, what we have done in this particular project, we can read and write the CSV file. We can read the Excel file using the sheet name, using the Pandas libraries. We can store query data in the SQL. We can fetch the online real-time data using APIs, and we can identify the missing values. We can explore the data. Now you guys just take any other public API files, like I have provided here one link for the Bitcoin prices. Just try it, get the real-time data from here, convert those JSON file into the data files, and convert it into the data frame and start exploring. So by the end of this course, you should be ready not only from the module 5.1 where you like set up your environment. From this you will able to handle like import, explore any kind of data sets, be it real-time data, be it CSV or Excel. Okay, now for this particular data set I have used the tips data set. I have used the exported Excel demo, that is only the tip data set that we have used, and we have used the API JSON placeholder. Now this module is complete, and we will move to the another module in which we will discuss the data cleaning and data pre-processing in detail. So stay tuned. I'm coming up with the next module for the data cleaning and data pre-processing, which is a very important and very essential aspect of data analysis. Thank you. Now in module 5.3, we will discuss and we will learn the data cleaning and pre-processing, which is a very important aspect of any kind of data analysis. You need to learn how to clean your data. You need to learn how to pre-process your data, because from here the actual data analysis starts. Because you cannot expect that you are getting the very clean data. You will get, most of the time you will get very messy data. So cleaning and pre-processing is an art, and you are going to learn it today. So in this module, what we will cover? We will cover the following thing: understand, how to understand and inspect the data, then how to handle the missing data, then we'll learn about the string cleaning, like how to do the text pre-processing, then the data parsing and feature extraction, then outlier detection and how to treat them. Then we'll learn about the data encoding also, like how to label and doing one hot encoding. Then we'll learn about the scaling and the numerical data of the numerical data. Scaling, normalization is extremely important when we are using the data for the different type of comparisons. So we'll see what kind of normalization we can try, min, max, standard, and all sort of. And at the end, we'll see the NumPy for the refreshers, like how you can use the NumPy for doing these data manipulations and data cleaning. And then a little bit of the Pandas deep dive. In Pandas, we'll learn about the functions like join, groups, and filters. These are the most important libraries, NumPy and Pandas, for you to read, write, inspect the data, manipulate the data, clean the data, and pre-process the data. So I hope you guys are ready to jump into the section number 1. So in this, our overall objective will be to learn how to prepare the raw data for the analytics, for handling the machine values, the tags, dates, encoding, scaling, and all those things. So the first thing first, we need to import the library, Panda library. We need to import the NumPy library, or depending upon from where we are going to get the data, we need to get those kind of libraries. For instance, in this exercise, we'll get the data from the Kaggle. So you need to install this, the Kaggle hub. I have already installed it, so I will not run this command. I will show it to you. And then there are other commands also, like strand scaler, label encoder, one hot encoder, max scaler. These libraries need to load. If you don't have these installed, then use pip install for installing these libraries like sklearn and all those things. Okay, so we'll go environment, and our environment, if you remember correctly, our environment was this one. The data cleaning, as I mentioned here, the libraries we will have is the pandas, numpys and sklearn libraries. I have already imported the kaggle hub. You can install this library if you don't have it, and then import os library. You can select the data set. Here we are selecting a database of Netflix customer churn dataset. This will provide the information when the Netflix customer stop using the service. So this is the dataset available at the kaggle. You can easily download it. So now for this, when we loaded the library, you can use simple command of kaggle hub dot dataset download. By using this command, you can get the path, and by getting the path, you will get the list of the files available in this downloaded dataset. If you run simply this command, it will give us the file that is downloaded, because we have the files in the directory path. It's just downloaded. This file can be loaded. You can define the file path, you can read the, or you can directly read the file. So in this location, in my directory location, this file is there. If you don't add file here, wherever it is, like you can just define your directories. If it is in downloads, you can go to the downloads. If it is in your working directory, you can load it from the working directory. You just need to define the path. After defining the path, you will able to load this file. Now this file is loaded. Read CSV function into the data frame. Now you can inspect the data frame like df.save. It will tell you like how many rows and how many columns you have. So we have 5,000 instances. We have total 15 columns. You can do df.info. I'm just running one by one. So info, you will get the information about all the columns. The first column is the customer ID. The second column is the age. Third column is gender, like that. And you will get the non-null counts also. Like, so most of the columns, most has no null values, but you will get the information about the data type also. Like this is the object, here is the integer, here is the object again, here is float, here is integer. So these information are also very important for you. By using the info command, you can use the describe command also. By using the describe command, what you will get in the head. So if you'll do the describe command, you will get the information about most of the numeric. What is a for each column, you will get the information about what is the frequency, what is the top value, what is the mean, standard deviation, minimum value, then 25% quantile, 50% quantile, and 75. You will get all the description of the columns that you have in this particular dataset. And then there is obviously one command of df.head, and this command will show you the dataset. Like first 5 is the customer ID, age, gender, hours, last, and from region, device, these kind of information you can get. You can just read about. So this is a quick way to download the data from the kaggle dataset download. You download it, read it back, and inspect the data. Okay. This is the first command that is very, very important for you, and we have learned this in the previous module also. Once you load, you have the data frame ready, then you can move forward to the other steps. What are those steps? So we'll go to here. Now in the other steps, the first thing we did is the understanding and inspecting the data. You need to understand how, which column you have in the categorical variable, in which column you have the numerical variable, and in which column you have the other kind of variables. You want to use some kind of, let's say if you want to use the age column now for the classification, because this is a numerical column. If you want to use the age column as the for the classification task, then you need to convert this age column into the category. Okay? So those things you will learn, and that is the data pre-processing, that is the data manipulation. Now the first thing what we learn is handling the missing value. Handling the missing values, remember you have two functions that you do. One is the drop na, and second is the fill na. Doing that drop na and fill na, you need to identify how many missing values are there in the data. How we'll do, we have a data frame, identify the missing values by this. What this command is simply doing, this command is reading the data frame, is finding the null values and doing the sum. And if you'll see in total how many missing values are there in each of the column, age, gender, subscription type, watch hours, I think there are 0 none values. We don't have any missing value set. There is another command also, is .df none to 100. So now we are looking for missing values, not the total missing values, but percentage missing values. We can just add it here, and we can write, and in the percentage missing values, not getting any missing values in this particular data set. So if we are not getting the missing values, there is like no point when we will run this command, it will not remove any rows or any instances. So because if we will do the drop na function, it will remove the row which has the missing value. If we'll do this command, what we'll get, if there are any missing values, it will remove the rows. If you remember, what was the shape of our df? So the shape of our data frame initially was, I think, 5000. So this will come 5000, and the column will be, I think, 14 columns, if I remember correctly. We'll see it. Then we'll use the df.drop na function. If there is any row with the missing values, it will drop. And if rows, the shape again. If it will drop any rows, the row names, row numbers, or the instances will be less as compared to the original data frame. So these kind of checks are very important. So this is the first check. We have 5000 rows. After running drop.na, we have again 5014 columns, because with the missing, these kind of checks is very important for you. You can quickly run, and we have already seen we don't have any missing value in this data. Okay, if you have the missing values in the data set, you will get the reduced. Check which rows you have removed, how many missing values were there, and there you can definitely include a lot of other information. Like there can be a row, like right now you have 14 total 14 columns. You can define, okay, if there is any missing values in any of the column, you will remove the row. Or you can define this function, like if you want to remove, if there are missing values more than 50% of the columns, then you will remove that row. That's completely up to you. Or you can go column wise also. Now after dropping, you can go to filling missing. Now filling missing data works very differently. So let's take all the three functions data, and we can do one by one. Okay, this function will also not work because we don't have any missing values. But let's say we are doing fill numerical column with the mean. In the age column, we are taking the age column, we are saying fill na. If there is any age column, fill it with the mean of the age column, and that mean value you can use to replace any missing values or any value in that column. This is one mode. The second, fill categorical column with the mode. If you have any categorical column, like gender is a categorical column, in that you cannot use mean because mean will not be computed. So in that you can fill that with the mode. Okay, you can do fill using forward fill, useful for the time series data. If you have any kind of time series data which is going like up or down in a specific order, then you can use either forward fill, or you can use either that you can do to fill the information. I will do this, but this won't change anything in our data frame. We can quickly check. So before doing the check, we can do like df dot head. This is our data frame. Okay, and we can do df dot head. And again, after doing all the filling and information that we are doing, there is some problem here because age was not expected in this. So we'll go one by one, we'll inspect it. Let's remove this first. Perfect. Why we are getting this error? If you read the column names, we have the age, but we don't have the age in capital A. We have a small. Okay, we'll do this again. And if we will print, we are doing print df head, I don't think this will change anything. Before that we are printing the information, and after that again we will print the information. Print df dot head this, so it will print two times. So this is after we are printing this again. Okay, and if you can quickly go and inspect the age column which is here, it won't change age, there was no, but if there are any missing values, it will fill with the mean values. The same way you can repeat for the other things which we discussed, you can do for the GI. Okay, so here what you are learning is three type of numerical data. Then you will use mean for filling. If you have a categorical data, this gender is also not capital. If you have the categorical data, you can use mode. And if you have a time series data, then definitely use, just looking for the subscription type, which is this exactly. If you have a time series data, then go and use the forward fill or backward fill approaches. Okay, is hanging a little bit, just hanging. So I will write here the subscription type, and this is like the time series data, let's say. So if time series data, you can use the forward fill or backward fill approach. So you need to first inspect whether there are any missing values. If there are any missing values, if categorical or numerical or time series, based on that decide which function you would like to use or which method you would like to use to fill those missing values. This is the one task. Okay, now After filling the values, dropping and everything, we can go to the string cleaning part. And string cleaning part is also very important when you need to do the text pre-processing. This is like simple clean inconsistent information. So inconsistent information can be anything. That's, let's say, if you have a country name and which is written, if somebody is written, some things are written in the caps lock, some things are written in the lowercase letter or uppercase letter, so you can change those information to make everything very consistent. I can give you some of the examples. Let me load it and do these, and you will understand why the string cleaning is important. So for the string cleaning, what we are doing, the lowercase and strip in the country. So if we'll see simply here, we'll see, so we'll get an error because again country is also small c. I think we'll check if we have the country information here or not. We have the, I think not the country, but we have the reason. I don't know whether this is the information name or not. Okay, so instead of the country we have the reason, so that's why we are getting it. We are not seeing anything, like everything is pretty much formatted and everything. But what if somewhere it is written small EUROP, somewhere it is written capital EUROP? So in that case you need to run this command to convert string lower strip command. You can replace the typos if there are any typos. You can replace, so in the gender part, if there is any inconsistent names or typos, so you can do like male to female, male to male, like that. So like we are just replacing everything. If there is any small male, you can do capital male, male information. So inconsistent type you can handle here. Now in the reason, removed unwanted characters. If you don't want any kind of characters, no, you can simply go and remove it. It won't affect anything here, but you can do it and check it. Like you want to replace the string, anything which is starting from A to Z, small letters, replace it with nothing. You can do it own. And what it will change in this particular data frame, it won't change too much. The only thing it is changing is because we are converting everything into the small case letter, and it's changing into the small case letter from the uppercase letter. Okay, so this is the string type of functions. So you can do multiple things. You can convert into the small letter, you can give the different names to remove the inconsistent names or typos, and you can remove the unwanted characters also. Okay, I don't know whether we have monthly revenue data here available or not here also, but then in that case you can use the quartile information for the other part. Let me just quickly go and try it. Okay, we'll try it on the watch hours. So we'll see the watch hours. Watch hours is our float data, not the integer data. So we'll just check whether it is working or not. So we'll check watch hour first quartile, third quartile, and we'll get the interquartile range. Okay, so we can simply print also, like what is our q1. Okay, quartile 1. So we are looking for the watch hours. Quartile 1 is the 3.33. What is the quartile 3 for us? Quartile 3 is 16.3. What is the interquartile range? Interquartile range is q3 minus q1. So this is what we are doing. We are taking the data, the numerical data, and we are dividing it into the quartiles. Quartiles like 25% of the quartile where data belongs to, 75% of quartile where data belongs to, and then using the 75 and 25 we will define the interquartile range. And this interquartile range is very important to get the lower and upper threshold to say something as an outlier. Okay, so there are some outliers. How to find the outliers in that case? Once we define our range, q1 q3 interquartile range, and by using this formula, q1 minus 1.5 interquartile is a lower range, q3 plus 1.5 into interquartile range is our upper range, and whatever is lower than, whatever is there below the lower range, whatever is there greater than upper range, that is our outlier. So how many outliers we have? We are just printing the length. Okay, we are printing the length, but we can print the outliers also. If we'll print the outliers, what we'll get? These are the outliers. So how you will define the outliers here? How will check? Because this is outlier, this instance, because the watch hour for this is greater than 40, 43. But what is your range? Interquartile range. What is your Q3? So your Q3 is here. We have already checked. What was our Q3? Our Q3 was, I think, 16 something, 16.03. What was our IQR? Our IQR was something 12.69. what was our upper cutoff? So our upper cutoff was 35. So whatever is above 35 is an outlier for us. What is our lower cutoff? So whatever is less than -15 will be the outlier for us. So here you can simply go to the data set and check how many outliers we have. Okay. So this is a very important data exploration that you do for the numerical data to identify and to detect the outliers. Define the 75% of the data where belongs to 75, define the IQR, using that IQR define the upper and lower thresholds, and from that you can get the outlier. This is what exactly you see in the box plot. I will explain it to you. Okay, now how you handle the outliers? There are two ways to handle the outlier: either remove the outliers or use the cap. I will do, we'll try one or two options, whatever is working for us. Okay, so when we'll go to the outlier removal, okay, so in the outlier removal, let's say the first option is to remove. So for us, this column is not the monthly revenue, but this is a watch hours. So for us, if it is a watch hours, we are saying that whatever is greater than lower, whatever is greater than above, remove. So what we'll get is DF clean. Okay, this is the one way to removal. Now you can quickly check what was the shape of DF, and then you can check what is the shape of DF clean. Let's see if it is removing only the outliers. Okay, why I am using this parenthesis? So it's not printing both because I haven't used the print command. If I will use the print command and if I will run it, so how many outliers it has removed? The total instances and total rows we were having was 5000, and right now we have 4762. That means the total outlier was 238. Those outliers are removed. You can quickly go and check which those outliers are. It's very, very important for you to know what option you are using to removing the outlier. There are other ways also. You can do the cap using clipping. You can use the upper and lower cutoff, and you can just do the clipping, but it will save and edit the data into your original data frame. I'm not doing this, not running this command. You can check it by your own. Okay. After the outlier handling, you can go for the data encoding. This is very, very simple but very, very important part. Data encoding is important. Okay, when you are, we'll see whether we have the subscription type or not. I think we have. So in the data encoding, you label the encoding with the categorical data when you have some kind of types there. Okay, so we'll see what is there in our data file. So in the subscription type, I don't know whether we have the subscription type. Yes, we have the subscription type. So first we'll see what subscription types looks like. Okay, so before running this, I'll take this little at the top and we will see the subscription type, how it will look like. Okay, so subscription type df, and then type, and so subscription type for us is a standard, premium, and basic. Okay, what we are doing, we are using the label encoder ali, and now we are changing the subscription type. Let me see how it is changed. So we are creating a subscription code instead of subscription type. Okay, so we are using this transformation from the subscription type to subscription code, and then we'll see how it is changing. Okay, so this is our subscription code and this is our subscription type. If we'll run this, so now what we have done, the basic is converted to 0, premium is converted to 1, standard is converted to 2. So now we have converted the categorical data into the numerical one. This is extremely important when you are creating some kind of, when you need the numerical data. If you're doing the regression or something like that, you don't need the classification data, then this kind of encoding is really very useful. Okay, now another kind of encoding, I don't know whether this kind of encoding is useful for you because this is based on the country, but we have the reason. But you can try this kind of encoding also. This is also one hot encoding that you can try on the data. The ultimate idea is to convert your categorical data into the numerical data that you can use in your downstream analysis. I will just write this command also in that model where you will get, you can give it a try. Okay, now after this we'll come to the scaling numerical data. Now scaling is extremely important because we need to normalize the data ranges for model training, for different kind of comparisons. Now, what kind of scaling you need to adapt, and that you need to decide which kind of scaling you want to do. You want to do the scaling from 0 to 1 range, 0 to 100 range, 0 to 1000 range, or in the some other kind of different range. So you can use min max scaler or anything that you want. Okay, the scaling mostly we do for the numerical data. So now when we come to the scaling part, now again we will go to our columns, what we have. And in the columns, instead of we can use the watch hours instead of revenues. Okay, we'll just try the watch hours. Okay, if we can do some scaling. So we are using the min max scaler, revenue min max, and we are doing this for watch hours, and we are doing watch hours min max. Watch hours min max. Now watch hour min max is our normalized data, and this is our actual data. We can quickly see how this scaling affects. So when we do the scaling, this is the min max scaling, in which you see everything is scaled in the values from the 0 to 1. So it can be done like simply by totaling everything here and dividing this by that total. So you will get range of everything 0 to 1. This data is extremely important because this data can be used for the model training. This data can be used for direct comparisons, because now you don't have too many outliers, or you don't have like too much uh, distribution of the data. I would say too many high values, too many low values. So this type of normalization is important when you are comparing or when you are doing the model training. This is a 0 to 1. Now you can do the standard scaling also. Standard scaling you can do by using the stand scaler command, and in the stand scaler again we will do the same thing. Now just the only thing we'll change is, instead of min max, what we'll do is, instead of min max we will do watch hour standard. Now watch hour standard is here, and your watch hours are here, because we don't have monthly revenue. If you do the standard scaling, you will get something like this. In the standard scaling you will get some minus values, plus values also. So you will have a whole range from minus to plus, and again the normalization is the same. So now the question is, what kind of normalization you should do? So it's not recommended without looking at the dataset, but you need to look at the dataset. You need to look at the distribution, frequency distribution of the data, and then you need to decide which normalization is good for your dataset, for the comparison across group, for doing the different kind of models that you would like to build on. So you need to decide. You can try two different normalization. You can do the downstream analysis, check the insights, and you can come back to the normalization again. It's completely up to you which normalization you would like to use further. Okay, now so far we have learned a lot of things from start to end. We have learned like how to handle the missing data, how to do the scaling, how to do convert the categorical variable to the numerical variables, how to do the outlier detection. Those kind of things we have done. We haven't checked the date parsing and the feature extraction here, because we were not having the exact column where we can try this, but I have provided the code, and that you guys can try whenever you are getting or working with the real data set. Now we will directly come to the NumPy. NumPy is mostly very important for the data manipulation. Both NumPys and Pandas, they are very important and libraries, and these libraries are very important for you to explore any kind of datasets. So now I am not trying these NumPy libraries or NumPy's function on the dataset that we have loaded, but we'll simply check what NumPy libraries can do for you. Okay, so now NumPys, you need to first import the libraries, import NumPys and NumPy. If you don't have it, you know how to install it. Either you will do pip3 or you will use pip, whatever pip version you have. Install NumPy, simple. If you already have it, no need to do it. Now array operations. So what you are getting, you can generate different kind of arrays. You can print it. You can get the mean of the arrays. You can get the square of each elements. So if you remember correctly, in the module when we were learning, we were creating a function. We created a function to calculate the square of the list that we are providing. Here in the NumPy, the function is already inbuilt. You can simply use this. So before doing the broadcasting, I'm just deleting it. Let's check this. We are creating an array of 1 2 3 4 5. Then we are printing the mean of this array, and then we are calculating the squares. So this is the mean of this is 3, square of each element is here. Now we can do anything that we want here. This function is inbuilt. We can do the q, but we need to change this square to each element, because this is just a printing statement. We can do anything that we want. If I will simply change this to little bit more, and if I will do this, it will change the mean, it will change these squares also. I need to put the square here because it's printing these squares, so something like that. So actually the NumPy is very very powerful when you need to do some numerical calculations. I'm just showing it to some kind of data which you can see here, but you can change it to any data frames. You can do the same things using the NP. You can compute the mean of any of the data frames. I don't know if you want to check. See, you're using the NumPy function. If you remember our data frame in which we have a age column, okay, in age column we can quickly get the mean by using the NumPy function, np.mean. Define that column and you will get it. So this is the power, of the NumPy functions that you can keep consistently using. You can use the watch hours. What is the mean of the watch hours? We can simply do np mean def dot watch hours. You will get the watch hours average mean is 11.64. So whatever functions we were doing, we were seeing the mean, mode, median, we were calculating the IQRs, we were doing those things. These things can be done simply by using the np, by calling the NumPy function here. Okay, now after doing the NumPy, so NumPy, I just don't want to stop here in the NumPy. Using the NumPys you can do whole lot of things, whole lot of numerical calculation. Try it, whatever we have done without using the NumPy functions, try to do it as much as you can here. Okay, then let's start the Pandas. Pandas is very very important to, you have already seen, to load the files, to do the join function, group function and filter functions. Let's read and write what we can do here. Okay, so selecting and filtering, this is one of the aspect. Now in our df we don't have the country, I think we have the region. Okay, so if I will do df dot head, again I need to repeat it again and again. So here we have the region. Okay, so region, so instead of this I will do the region. Now I will search for because I'm filtering, so I will search for India. Will not be there because the regions are different. So this will be, let's say, the Africa or Europe. I will define the region Africa. Now I will go to the get the gender, get the subscription type, which is subscription type, and get the what, watch hours, WATCH watch hours. So now you can use this Pandas to select and filter the specific part from the data frame. Let's run it. So now what we are getting is, so in the df we have selected and only filtered the Africa region, and for that we are just getting the column called gender, subscription and watch hours. We can, if you want, just to match whether we are getting the same column or not, we can check, we can add the column region also. Okay, so now we are getting only the data for the Africa region and we are getting the selected columns that we want. So this is the power of Pandas. I forgot to tell you again, you need to load the Pandas the same way you did for the NumPys. Import Pandas as PD. That is what we are doing here. Okay. Now, if you will do the concatenation, if you have a DF, you can do the head, tail, and the concatenation. I'm going to this part. Okay. Again, I think there is some error. I will go here. Let me just refresh it. I restarted the module 5 because it was getting some trouble in loading. And if you remember where we are right now, we are at the selecting and filtering that we are doing using the Pandas. So this is the command that we were running, and after that we are pasting. Okay, so now we are taking from the df our data file. We are getting df1 500, df2 500, and then we are doing concatenation, and then we'll get the shape. So these things you can do. Now you are selecting top 500 instances, bottom 500 instances, and doing concatenation. So you will get total 1000 instances in the same type of columns, 17 columns. Why we are getting 17 column, you remember? Because we were initially, how many columns we were having? So if we'll go to the df concat or like df, only df, initially we were having only 14 columns, remember, but we added subscription code for the, if you know, subscription type, we were having the object and we converted this object categorical data into the numerical data. So we're getting subscription code, which is integer, and we convert the watch hours. The normalization we did is the min max from 0 to 1. The another normalization for watch hour we did was the watch hour standard. That's why we are getting now total 17 columns instead of 14 columns. So these type of things we can do. Now in Pandas, merge and join function can be used. So try the merge and join functions using the data frame option, pd.dataframe options. Try this pd merge instead of getting or selecting the data. Merge based on the columns, based on the left merge or right merge. Try these commands, merge and join by group by functions, and these information will provide this will provide you a lot of other information. I can just give you the example of the group by function here. You can simply try the merge function using the pandas library. Okay, we can try and check this one. Df group by, what we are doing is subscription type is the subscription type, group by subscription type by watch hours. For us it is watch hours. Okay, now what we are doing is do mean, sum and count. What we are doing, group by function, subscription type by watch hours. If we'll run this command, we'll get something like this. Subscription type is basic, premium and standard. What we are getting is mean, sum and count for each subscription type based on the watch hours. You can change whatever you want. You can change the age here. I don't know. We can get the watch hours mean count for all age types. Now age, if you remember, we don't have the age as a categorical variable, we have numerical variable. So we are getting for this, you can convert this numerical variable to the categorical variable, like less than 25 age, younger, older, or kids. You can divide that and then you can do the computation again. So whatever you want, you can use this df group by function and summarize your data in the way that you want. Okay, so group by function is also very important. Now for you, optional practice task I have already written. Handle the missing data in the age using the median, because we have explored this data with the mean. Or you can take a data set with the age column, there you can put the missing information there, put the NA values there and then handle it. Encode the gender column using both label and one hot encoding. Select both age and monthly revenue. Instead of monthly revenue, what you will go here, like watch hours using strand scaler, because we did the strand scaler for watch hours. You can try for the age and watch hour both. Then you can explore other data columns. If you have the other data files in which there are different columns, different categorical column that you want to convert into numerical, different numerical column in which you would like to do different kind of normalization, min max or strand scaler, or different numerical column that you won't like to convert into the categorical column, try and play with it. Use numpys, use pandas to do as much as possible. So far, if I will quickly recap, we did how to clean text, date, categorical data, handling missing data. We learn how to remove and treat the outliers. We learn how to do the encoding for the categorical variable. We learn how to do the normalization, feature scaling, NumPy's vectorization, broadcasting, and pandas filtering, merging, and grouping. Now, I hope you guys will practice. You guys have everything set up. Practice everything from set up the environment to loading the data, and from the loading the data from CSV, Excel, whatever files it is, and then here cleaning and pre-processing the data. Then get ready for the module 5.4, in which we learn statistics in detail, statistics in Python. Stay tuned. See you in the next video. Hello and welcome to the module 5.4, and in this module now we will cover the statistical analysis in Python. So we'll learn little bit of the concepts of statistics, how you can compute the stats, initial stats, descriptive stats in Python. So far what we have learned, we have done the getting started with Python. We have set up an environment. You can write down your first Python code is either in Jupyter notebook or in the Colab. Then we learn how to import and explore the data. Then in the third module, we learn about data cleaning and pre-processing. And this is the step where we'll explore the statistical analysis in detail. So in this course, what we are going to explore in this particular module is, first we will learn how to describe and summarize the data using the measures like mean, median, standard deviation, and percentiles. Then we'll learn and understand about the probability, like the foundation of uncertainty, randomness, distributions like normal distribution, binomial distribution, those things we will learn. Then we'll learn about the sampling and building the confidence interval. In the last module also, we learned about how to compute the confidence intervals, and those are important to detect the outliers. But here we learn how to build the confidence interval, use them as a concept as a central limit theorem to generalize the insights from the smaller samples and from the larger populations. After that, we learn about the hypothesis test. Hypothesis testing, like just to check the significance, like when to do the t-test, when to do the chi-square test, how to interpret the p-values, significance, and the statistical power. Then the difference between the correlation versus causons, like when we are doing the correlation analysis, what we should be careful of, what can be the confounding variables, and all those things we will learn about this. After that, we'll learn about build simple and multiple regression models, like to do the regression analysis to identify the relationship between the predictive variables. To this actually regression modeling helps us to do the predictive analytics. Then we'll learn about the AB experiments, AB testing, and all those things. If we'll have time, we'll learn about the time series data also. Now, we are not going to explore this in the Excel. We will explore each and everything, whatever we have discussed, from describing the stats till the A/B testing, everything we will do in Python. Are you guys ready? And we will just try to explore each and everything in detail. So we can start from the descriptive stats, and that we have already seen in the past also, in the previous modules also. And those are around like mean, median, mode, range, variance, standard deviation, getting percentile, getting interquartile range, using the interquartile range, get the outliers, and those outliers you can use for cleaning your data sets, and then using pandas and numpy in this module we'll see. So for the descriptive stats, before going into the codes that we have written in the numpys and pandas, if you remember from the last module, we have a data frame, and that data frame is from the customer churn, Netflix customer churn data analysis. And in this data, if we'll see, we have around 14 columns, and we have around 14 columns in total, and we have non-null values, and we have around 5,000 instances in total. Okay, so from this, we can keep exploring each and everything. Like we can define the column name, and we can identify which values we would like to explore, how much is the shape. We can identify the non-unique values. We can do whole lot of things. We can go to the descriptive stats. We can compute the mean, mode, median, everything. Like if we'll go to the descriptive stats in simple, we can write the data frame, we can write the column name, whatever column you want to explore, and we can just check whether it is working or not. So you can get the mean, you can get the median, you can get the mode, whatever you would like to explore in the descriptive stats. So if you'll do the mean, you will get the mean of all the data frame. You can check what the data frame age column look like. Is the numerical column. If you'll see from here, you have all the columns. You know the age is an integer or numerical column, and you can explore it. So like if you'll do mean, you will get this. You can get the median. Reload it. I just reload it because it got hanged because of some reason. I'll paste it again. Yeah, perfect. So in this, like I have written, we can get the mean, we can get the median, we can get the mode. Mean is the arithmetic mean, median is the middle value, mode is the most common value. Then we can get the variance, we can get the standard deviation, we can get the mean absolute deviation. We can explore whatever we want. So this is all about the descriptive stats. This is how we know about the data. So you pick the variable that you are interested in. Right now this is a age. You can pick any other variable, and you can explore that data set to the hell, you know. So if I will do the quartile also, I can get the mean, I can get the max, and this is the function. I will not just put it, I'm just doing it. If I will run it all, there are some errors at some places, and which is I think mean absolute deviation that we are not getting, but we will run it again. Rest of the things, the last you are getting is the max thing. We can print it each and everything, and then we'll know what is the mean, mode, median, but I'm right now not printing it. You can run these commands one by one, okay, to get whatever statistics data you are interested in. Now if you would like to see the complete function, so describe function will do everything for that. Every stats that we are computing one by one, describe function will do all at once. So you can run the describe function, and for age you are getting the counts, you are getting the mean, you are getting the standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile, and this is your IQR range, like from 30 to 58, and you can get the upper or lower bound to detect the outliers, and you can get the maximum value also. So the describe function do everything, but I just explained it to you so that if you are interested in a particular variable, you can get these statistics for any interested column that you want. Okay, I hope it is easy for you and easy to follow also. Now we'll simply go in the if you would like to use, let's say, pandas or numpys, so I will simply copy this example code from here. Okay, and I will show you how to compute all these using the pandas and numpys also. So in this, what we are doing is we are loading the pandas as a pd, numpys as the np, and we are defining the as column. We are creating a data frame, and now we are converting this data into df. So let me do this df1 so that I am not replacing the previous data frame. Okay, and if I'm doing df1, I need to change this df1 at all places, so that from here onwards I will not use df, I will use df1. Okay, so that's how I knows that I'm working with the new data. Okay, so we'll get the data. From data we'll convert it into data frame, and then we are getting the mean age again using the mean function. We are getting the median, we are getting the mode, standard deviation, variance, range, q1, q3, and the interquartile range. And this interquartile range I mentioned can be used to detect the outliers. We can simply run this and we'll get everything: mean, median, mode, standard deviation, interquartile range, and everything. So you can explore each and every statistics parameter using these commands, or you can use directly the describe function for the variable. Now for instance, if you have 100 columns or 1000 columns variable, so you need to put this in the loop. You'll put in this in the loop to check the stats of each and every column you are interested in. Okay, now another thing, if you have a lot of columns and if you just don't want to read the numbers, then another important thing here is you can go and plot a histogram plot. You can draw a plot. By that you can get the frequencies, you can get the distribution, and for doing that you simply need to load the function called matplotlib, library called matplotlib. If it is not installed, you know how to install it. Again, pip3 or pip whatever version you have, install matplotlib. The library will be installed, and then you can call this function as a plt. Now from df1 we are taking the age, we are dividing it into the 5 bins, and we are doing the plot titles like age distribution, x axis is the age, and y axis is the frequency, and we are doing the plot. So let's see how the plots looks like. We are dividing into the 5 bins. So the total age is distributed like this. So between 20 to 25 we have total 5 individuals, between 30 we have 2, 35 we have 2, 40 we have 1, and 50 we have 2 individuals. So this frequency distribution help a lot to understand the distribution of the data. We can divide this bin into whatever bins you want. If you will do 2 bins, so it will just create a histogram of 2 bins, like less than 36 or more than 36. Okay, so you can define the bins, you can change whatever you want depending upon how rich data set you have and how much you would like to explore it. After this, the important concept that we need to learn here is the probability essentials. In this, there are important things such as random events, outcomes, probability. You need to understand what kind of data type it is, whether it is continuous or it is a discrete. Then you need to understand the binomial and normal distributions. To understand what kind of test you need to apply it in future, like whether it should be the parametric test or it should be the non-parametric test. We'll again take the code example from here and we'll learn each and everything one by one. Okay, so from here I'm just taking the code example. I'm taking the example, I'm loading again numpy as a np, matplotlib, and skipy and binom. Any of the libraries which you don't have, use pip install to install it. Now what I'm doing is I'm creating a random range and I'm checking the binomial and normal distribution of this type of frame. I'm flipping the coin at the 10 times, and for that I'm just checking their distribution in this plot. So again, this is the binomial distribution in which I'm getting the probability and I'm getting the success. What is the probability of these when I'm flipping the coins of getting this? So like getting the probability of getting 7 is highest, getting the probability of 7 8 is the around 0.15 or 0.10, and this type of distribution you can get in the normal distribution also. So it's up to you what kind of plot you would like to make. You have the data, you can go for the binomial distribution and you can go for the normal distribution also. And you can, by just looking at this, you can decide. If you have a well normal distributed data, you can go for the t-test or any kind of parametric test. But when the data is not normally distributed, it is skewed, like at one place it's higher value at the left hand side or at the right hand side, then you need to decide what kind of statistical test you are going to perform later on. Okay, so it is important for you to check the distribution of the data and everything. Now sampling and intervals, as we have discussed already, if we'll take a population, if we'll take the sampling interval, that is also very important for us to learn here in this statistics specifically. So let's say we are taking the population and we are simulating a population, you know, and then we are taking the sampling, we are taking 100 samples from that population, you know, we are taking the mean and then we are plotting it. So sampling distribution of the sample means, this is very very important, from the population you are taking a subset and you are plotting it, you know, just to check the confidence of interval. So this part can be done. You're plotting the sample mean of the sample distribution and you're checking the frequency of all the samples. This is important when you are dealing with larger data set and you just want to do the subset from the data. You don't want to consider all the instances but the subset. You can keep on testing, you can keep on checking how much confidence interval you are getting by considering mean of the sample subset that you have selected from the entire population. So those kind of things you can do by random sampling and computing the means and CLTs from those populations. You can compute the standard error here, and from the standard errors you can compute the confidence interval at the end. Okay, so you took the mean, then from the mean and the samples you will get the standard error, and from the standard errors you will, at the end you will get the confidence interval. So here your confidence interval is 51.28, and this confidence interval help you to decide how to subsample your dataset, how randomly you need to select, how many times you need to select, or the subsample population that you need to get the most accurate or most significant results with the least number of samples. After this you come to the hypothesis testing, and hypothesis testing here is very very important in this. Like you decide the null hypothesis, that whatever differences you want to check between two groups is not true. That's your null hypothesis. You need to prove your null hypothesis wrong, which is alternative hypothesis, and this test your significance. So here there are a lot of things to learn. The first thing is to learn is type 1 error, type 2 error. Type 1 error is generally the false positives. False positive, when I say the thing, the actually the result is negative. The result is negative, but whatever predictions we are making is falsely we are detecting as a positive. Then there is a type 2 error which is false negative. Using the type 1 and type 2 error, false positive and false negative, we detect the significance of whether we are accepting the null hypothesis or we are selecting the alternative hypothesis, which is we are rejecting the null hypothesis. We can do some test here like t-test or chi-square test to check the significance, whatever different significance we are checking. Okay, here is again an example of the t-test and chi-square test. I will just take this up. So here we are taking again the library skipI. We are creating a group 1 random normal distribution, group B random normal distribution. Then we'll do the t-test. So for the t-test, we are doing the test between group A and group B to find whether group A is different from group B or not. So when we'll define our null hypothesis will be at the start. There is no difference between group A and group B. Now, if we need to prove this null hypothesis wrong, so we need to prove the alternative hypothesis is correct, means there is a difference. So if we'll get a significance, that means there is a difference. So this is a t-test, simple t-test individual group. And then for chi-square you need a matrix. Let's say you need a matrix of 2 by 2 matrix. In this contingency data you can compute the chi-square test. So for the t-test and chi-square test both, we will see t statistics. What it says is p-value is 0.02. Whatever is less than 0.05 is significant. So in these both type of data set, t-test is coming as a significant, and chi-square test is also coming as a significant. So significant is like there are 5% of the chances, then this might not be the true, but most of the time this alternative hypothesis is true. That's called point, if the p-value is less than 0.05%. Now after learning the hypothesis testing, there are a lot to learn here. I'm just showing you how to test these hypothesis in the Python environment. You can go back, you can learn a lot about hypothesis testing, you can learn a lot about p-values, type 1 error, type 2 error, false positive, false negative. Everything that we are discussing here, you can go back and learn about these things in detail if you want. But here you will get a quick demonstration that how to test any hypothesis that you have in your mind. Okay, then we come to the correlation. So correlation is generally when you have a big data frame and you want to identify the relation between two variables. Those variables can be anything. Those variables can be, let's say, the data set we were working, like customer churn Netflix data. In that, it can be the age, and it can be number of hours they are spending on the Netflix. It can be any numerical data that you can use for the correlation analysis. Correlation analysis is simple. You take two variables and try to find out whether there is any relationship between them, like be it a positive relation, be it a negative relation, and how strong that relation is. Strong means if you will just plot it in the scattered way, you will find it whether the association is strong positive or strong negative. So for this, like, you can either select any of the data frame that you are working with, or here what we are doing is, again, we are generating a x, we are generating a y, we are generating a z, and in this data frame we are computing the correlations between x, y, and z. And for the drawing the scatter plot, like, so this is, let's say, example of correlation. So we have, let's say, x, we have y, and we have z. This is the data that we are randomly generating, and then we build a data frame called df core. We can quickly check how the df core data frame will be look like, and we'll not do the correlation at the moment. We'll simply check the data frame df core. Okay, so this is our data frame x, y, and z. Now what we are doing is we are trying to identify the correlations between x, y, and x, y, and z, and for that we are doing this df core dot core. So by this doing the correlation, we'll get the correlations between x, y, and z. Now we can plot any two variables at a time. So here, let's say we are doing x and y, so plot the correlation between x and y, and do the plot. So you'll get this kind of correlation. So what we are getting here, there is a strong positive correlation, and we can do the testing here also whether this correlation is significant or not. Strong positive correlation, whenever the x value is increasing, y value is also increasing. You can go and label these plots like x level, y level, whatever we are doing here. You can just label them plot x level, plot y level, plot, so plot title. These things you can add if you want in these kind of plots. Otherwise, this is simple just to check the correlation. You can check the correlation between x and z. You can just change x and z. Correlation between x and z looks like scattered all over the place. I don't think there is strong positive correlation between x and z. You can check the relationship between y and z also, just to check whether there is any relationship. Y or z is also scattered. So now the only positive correlation it seems is between x and z. Oh, so only positive correlation is seems between x and y. Quickly check. Yes. So the x and y, and you can see the numbers also. In the x and y, the correlation is 0.98. That's like the correlation range from 0 to 1. 1 is the highest correlation, 0 is the least correlation. And when it is positive, that means if x value is increasing, y value is also increasing. So you can do the quick correlation test. You can do the correlation test on the big data frames also. Like, if you remember, we have a df is a customer churn, Netflix customer churn data, in which we have a lot of other information available. If we do the correlation analysis on the data frame, we can do simply df core and numeric only. And if we'll do this, I'm just doing the correlation analysis on this, and let's do this. I'm simply doing the correlation analysis here, and I will check the core among all the variables. And the variables we are selecting is the numeric, not all. And we'll get the information. So here is the correlation values that we are getting. Is there any association between A's and watch hours? No, least correlation. So from by just looking at this data, where you can find the maximum and minimum correlation. You don't need to consider the self association because it will be the max. It seems there is a strong association between the last login days and the churn, means when people stopped using the Netflix. And obviously last login days, if it is higher, that means the churn is, the value will also be higher. So that's how we are seeing the most strong correlation here. But you can plot it, the correlation thing can be plotted. So for the correlation, you can use the seaborn or matplotlib, and we can make a quick heat map. So in this heat map, we can see this data. Whatever data you are seeing here in the numbers, you can see this data in the in form of the heat map. So you're getting the numbers and the heat map, so you can quickly see which variable is correlated with which variable in the x-axis and on the y-axis. Higher the correlation is in the positive side means positive correlation. Higher the relation between negative side means negative association, means x value is increasing, y value is also increasing, or x value is increasing, y value is decreasing. So these kind of association correlations you can get. Okay, now this correlation, again, the one more concept that I haven't told you here is when you are exploring the relationship between features, it's very important to understand whether you are exploring the relationship between numerical versus numerical feature. So for instance, in the DF, if you are exploring the relationship between age, watch hours, and monthly fee, so this can be the pair plot in which you are getting the association between age, watch hours, and monthly fee. This is the data, and you will get something like that. You can see whether the age, monthly fee, age, watch hours, age and monthly fee, is there any association or not. You can do the correlation also, you can do the heat map also, but when you are doing the categorical variables, okay, when you are doing the relationship between categorical and categorical, so you need to do the PDF cross step. So let's say you are doing the relationship between region and payment method. So you just want to understand the relationship between, is there any association between the region where Netflix is used and the payment method they are using for the payment. So you can do the PD cross step here to understand the relationship. So here, like you can see, in Africa, Asia, Europe, North America, where the most of the credit cards used, or crypto used, or debit card used, gift card used, or PayPal used for making the payments. You need to understand if you're making the association or if you're trying to find the relationship between categorical and numerical variable. If you're trying to find the between categorical and numerical variable, like say you are taking the payment method and you are trying to find out the association with the watch hours. Is there any association, the payment method and the watch hours? It doesn't seems like, is there an association between payment method and watch hours? And if you'll test it, it should not come significant also. Just to remind you, whenever I'm using this data DF, this is the data, same data that we used in the previous module, and that is the data that I showed you about the Netflix, and which we loaded which we loaded here from the Kaggle. So in the Kaggle, we took this data set, which is Netflix user base database, which we downloaded and saved it in the Netflix customer churn.csv, and we loaded in the DF. That's why this database is already loaded to us, and that's why I'm exploring it. In this database, you can quickly, if you want, you can quickly check before doing this categorical numerical. You can quickly check again. If you forget, you can quickly do df.info and quickly check the data information. Again, like it has 14 columns, it has some numerical, it has some categorical variable. We learned how to convert the categorical to numerical variable, numerical to categorical variable. But still, if you would like to explore the relationship between, let's say, age or gender, age or device, between age and monthly fee, between age and churn, age and payment method, you can just keep exploring whether those data type are categorical or numerical, and then what method you need to adopt here. This is up to you. Okay, now at last you can just check the relationship between let's say you are just making ISNS box plot between the payment method and churn, and you just want to make a color or something based on the gender. So these kind of things you can also do. So in this, let's say you're just trying to see the churn data based on the payment method and just want to color that based on the gender. So it doesn't seem there is any differences here. I was just exploring. You can keep exploring the data as much as you want. Okay, after correlation, it's very important when you're getting some correlation results. So make sure those correlations might not be the same as Gaussians. Those are simply association that you are seeing that one factor is increasing, then other is also increasing. There might not be a real association between them, so you can test them using the hypothesis. You can consider the co-founders and all those things. You can keep exploring this data. Okay, now there is a, after correlation there is a regression, and regression is very important to find out again the relationship between two variables. This is good for the predictive analytics. When you fit the model, when you have a continuous variables and you have a one variable associated with the another, and if you fit a model, then for the unknown data you can predict what can be the prediction of the next data. Okay, code example we can use for the regression. So for the regression, let's say we are doing so DF core. So df core by x has some kind of data. We can quickly check because df core we just computed. So df core x has some kind of data, df core by has some kind of data. So we are getting x from here, we are getting by from here, and then we'll make is it as a constant, and we'll construct the model, we'll fit the model x on by, and then we can make the print summary. We are not plotting anything, we are just plotting, we are just making the model and making the summary. So this is the correlation regression analysis that we are doing here. So here you will get a lot of things, like you will get coefficient, standard error, t, p values, and you will get the confidence interval also. This is your model which is fitted. Ultimately the purpose is, when you have the fixed set of x values, fixed set of y values, you are fitting the model in such a way so that you know whenever you will get a new x value, you can predict the y values. So these type of regression models generally used for the predictive analytics. When you have certain patterns, you have certain trends, you would like to fit a model and you would like to predict it again. We can make a plot also. So we are making a plot, scatter plot, and this is just for making the title, scatter plot between df core x and y, and we are making the predictions on x and coloring it by the red. So when you will do this kind of predictions in the regression, we know in the x and y there is a strong positive association, but the red line we are defining is the fitted model that we are doing from the regression. Now whenever we get a new value like 60, we can at least predict what will be the value of the y. That will be around 120, because this is a strong perfect correlation. So regression is very good. You can infer this regression model, you can explore this. Most important part here is the r square that we were getting in the regression analysis. R square shows how strong that association is, and then for us the most important is the probabilities and p values, whether those association are the strong significant association or not. So those things you can check. Okay, now moving back to the our main part, this is the regression that we are doing with two variables only. We can do the regression with the multiple variables, and we can do the model fitting, and we can print the model summary. When you have, let's say, predictive variable which is y, and when you have certain variables x1, x2, x3, x4, it can be anything, and you are trying to fit a model, trying to find out the association of the predictive variable with all the observed variables you have. So let's check the random example, and then we'll quickly do the model summary that we have done for the regression of the one variables, two variables at a time. So in this we are getting x1, we are getting x2, we have the y variables, and then we have this multiple data frame in which we will have x1, x2, and y. We'll fit the y value again all the x values that we have. Okay, if we'll do this, we'll get a model fit. So now this time when we are getting a model fit, in this we'll get the information about x1, x2, and the y, both the variables, association of both the variables with the y variables. So this is the regression fitting that you can use if you have a data frame. If you would like to regression modeling, you can consider all the numerical variables against the predictive variable that you have in that particular data. You can keep it exploring, read about each and every observation that you are getting after doing the model fitting and everything, and you will learn about it. Now there is experimentation, A/B testing, and this is again very important. When you do the t-test, which I already showed it to you, you need to understand what is the effect size, which is very important. That tells us, the effect size tells us how strong the differences are between two groups, and p-value tells us whether that difference that we are observing is statistically significant or not, because we are doing the random by chance, and we just want to reject the null hypothesis all the time. Now, this I think we already tested, but we can do it again. For the A/B testing, we did at the start, we did with the chi-square test and with the A/B test. So we are getting the data A, we are getting the data B, and we are doing the t-test between A and B. We'll get the effect size, we'll get the p-values. We'll do t-statistics. So this is the effect size and this is the p-value. P-value is 0.001. That means the difference between the data A that we are generating, random data, normal distribution, and the data B, which is again random data, normal distribution, the difference between A and B is significant. So these kind of testing you can do. This is A/B testing. Identify the effect size, identify the p-values, and you are good to go. Then you can go for the time series data. I would just open this code prompt for you guys just to check and see how you will do with the time series data. So in the time series data, you're getting some dates, you're getting some sales. You will create a data frame, and then from the dates and sales you can just plot the sales over the time. So this is the time series data. In the time series data, if you remember correctly, uh, you can find out the associations here, you can find out the correlation, regression, p values, significance, effect size, everything here. But the good part of the time series data, when you are dealing with the time series data and you need to do the filling of missing values, if you remember from the module uh, uh, 5.3, there we discussed, if you have the time series data, so don't use the mean, mode, median for the filling. If you have any missing values, what you will use here, you will use either forward filling or the backward filling options, and those options I have shown you in the past. Now you can check each and everything whatever we have learned so far. You doing the t-test, doing the correlation, regression, load your data, whatever data you have, whether it's a Netflix churn data or iris data, tips data, load these data sets, do the descriptive functions, do the correlation, do the regression, do the A/B testing, find out the effect size, find out the p-values, do all the heat maps of the correlation that are required, explore this as much as you can. And then by the end of this, if you will practice enough, you will have enough information about how to describe the data, how to do the normal stats, how to do the stats to understand the relationship between the variables, how to do the forecasting, all the things you will be get ready with, and those are very essential component of doing any kind of data analytics. I hope you will follow up with this. You will practice the commands which we have discussed, and then see you in the next module where we will discuss and learn about advanced data analytics. Thank you so much. Hello and welcome to the module 5.5, in which we will learn about advanced data analytics techniques. So far in this Python course, what we have learned is getting started with Python. Like we have learned how to install the libraries, how to install the Python and the additional libraries using pip and all those things. We learn how to use Jupyter notebook. We learn how to use Google Colab. Then in the second module, we learn about importing and exploring the data. Then we followed the data cleaning and pre-processing step in the module 5.3. Then we learned a little bit about the statistics, like how can you do the statistical analysis specifically in Python. These things are very, very important for you to get started and to get to move forward in any kind of analytics you are doing. These steps are most important steps. Now when you are here, like you know how to do these things, how to do the data exploration, how to do the data cleaning, how to do the statistics and all those things, you might be wondering what else you can do. So there are n number of things that you can learn, and those comes under the advanced data analytics techniques. So briefly, let me tell you in this section specifically what you are going to learn, what we are going to cover. Again, for this advanced data analytics, we will use the same Netflix customer churn database that we have downloaded in our previous modules. I will specifically show you from where to you can download this. You can just go to the Kaggle and download this. I will provide the link for this data set separately. Okay. The tools that we are going to use in this, mainly the Python, obviously, the Pandas libraries we will use, NumPy's libraries we will use, scikit-learn we will use, matplotlib and seaborn for the visualization. Scikit-learn is specifically for the like correlation and regression and any type of machine learning that we will do. Pandas and NumPy's, you know, for data manipulation, for data cleaning, for data loading, everything you need these kind of libraries. So learning objective is specifically what we will focus, like by the end of this module you will able to learn like how to prepare your data for modeling, specifically when you take your complete data and you are using this data for the modeling. You need to divide this data into the training and test sets, and on the test set you validate that how your model is performing, the model's accuracy and everything. So we'll learn how to split the data. We'll learn when you will split this data, how you can use the test data sets to check the accuracy and all those things. Then we'll learn about building reproducible pre-processing and modeling pipelines. After that, we'll learn about the applying like scaling, encoding whenever required. Like sometimes on the datasets you need scaling, sometimes you don't need scaling, depending upon how your data is spread overall looks like. Then the encoding, if you need to convert the categorical variable in the numerical variable, and vice versa. Okay, feature transformation and all those things. Then we'll go for the logistic regression models for the classification. After that, we learn about the most important thing, that is like how to measure the accuracy of different models. So for that, you can use sensitivity, specificity, ROCs, AUC curve, and for this you will use mainly the confusion matrix. So we'll learn what confusion matrix is, how you can compute confusion matrix, and how using the confusion matrix you can compute all these measures. Then we learn about hyperparameter optimization using the grid search CV, and last, the interpretation of the model outputs and the visualization of the results. So this is the overall focus of this particular module. So be with me, I will go like very slowly. I have taken a very simple examples. You can expand it as much as you want. Once you will learn the concepts, then you can change the data set. You can explore n number of directions specifically in this section. Okay, the first part, again we'll import the libraries. I will explain it to you what libraries we are going to export, and then we'll load the Netflix customer churn dataset. So in this, again, I mentioned the Pandas libraries, NumPy's libraries, Matplotlib and C1 for the visualization. Then sklearn is specifically when you are doing the advanced analytics tasks, specifically you are doing machine learning, regression, classification, then you need these things. In this, you can import the functions like test train split, grid search CV we discussed, strand scaler, one hot encoder, depending upon whatever task we need to do, you can import it. Okay, column transformer, then logistic regression, confusion matrix, ROC curve, OUC curve, these things you can just import in the library sklearn. If any of these libraries is not installed, you know how to install it. Simply go and do pip install and library name. Okay, this we have already covered in our previous classes. Let me make it a little bit zoom. After this, we are simply putting the displaying option for the clarity, and then we are loading the dataset. This dataset is already downloaded by us, Netflix customer churn database. You can download it like in the previous module. If you remember, I have already shown it to you on what line we are right now. Okay, so we can quickly go and see from the Kaggle database. I have directly shown you like how you can download this Netflix churn database. Okay, if you forget, I hope from the previous module you have already downloaded it and you have already saved it. So here I have shown you from the Kaggle hub. This is a library that you need to import first, Kaggle hub, and from the Kaggle hub you can download this Netflix customer churn database. You can directly download, and it was saved in your working directory, and it was my working directory, so that's why I'm directly loading. If you haven't done it yet, download it using Kaggle hub using the command line in the Python, or you can directly go to the Kaggle and you can directly download it from the website also. Okay, it's completely up to you. Now once you will download this dataset is ready for you to load. Okay, let me go to there. Okay, here we are exploring the advanced data analytics. In this, what I'm doing, I'm just using the PD function to read the file. So once I will read the file df, then I will simply print following things. I will print like how my dataset look like, how much instances like rows and column I have by using the df.shape command, and how datasets look like is df.head command. It will display first few lines. So if we'll run this complete chunk, okay, you can run like line by line. I am just putting all the chunks together and just running it all. Okay, so first you are getting the shape of the dataset. What is the shape? Shape is 5,000 rows. So that means in this dataset you have total 5,000 instances and you have total 14 columns. You can quickly see you have the customer ID in the columns. You have customer ID, you have age, gender, subscription type, watch hours, login days, a reason, device, monthly fee, churn, payment method, and lot more things. When you will change the data set, you will see your number of instances, your column will change. It is very important, extremely important before going to any kind of advanced data analytics. It's very important for you to know what kind of data you have in these columns, whether you have categorical data, whether you have numerical data, whether you have time series data. Based on that, you decide how you would like to do the feature engineering, how you would like to tackle those columns or variables in your model. Okay, so it's very important for you to know. So for data exploration, what you can do, first thing you can do df.info. This command will give you the information about each column. Okay, the data type, what kind of type is there and everything. Then you will check the missing values. If you remember from the data cleaning and pre-processing, we have learned about this df.is.null function, and we are checking total missing values are there in this data set. Okay, then you will take and check the value count in the churned column. Churn, like how many customers have stopped using this service, and we would like to analyze it. Okay, and in this we are doing the value count and we are doing the normalization is true. Okay, then there is a drop function, and in the drop function, so if we are going here, do we need this customer ID information here? Because we are not going to use this in the modeling. This is good for tracking if you would like to see some of the customer which are behaving like very differently from the others, and like some kind of outliers, then you can tackle them separately. But that information you can get from the IDs also. So like you don't need this customer ID information, so you can drop dot column, you know. So by df.drop function, you can define which column you want to drop, and then you can get the column list again. Okay, so this is just a simple data exploration in which what we are getting is these are our 14 column from customer ID to favorite genre. How many null values we have? None. All 5000 values are non-null. Then we are getting the data type. It's object, it's integer. Object is here like a categorical variable, and whenever we are getting the float, you know, it can be like decimal points also, and integer is a solid integer number that we have already discussed. Okay, so this is very very important for us to know about the data set we are just starting working with. Okay, now we have checked the missing values also in each and every column. How many missing values we have? 0. Okay, so we don't have missing values, so we don't need to go for the imputation. So if you remember in the missing values function, what if you are getting some of the missing values in the monthly fee? Lot of missing values. Okay, you are getting. Then you need to decide. You have total 5000 instances, out of which how many instances this value is not available or missing. Now you can decide whether you want to consider this column for your downstream analysis or not. So here comes the imputation strategy. Here come how you will fill those missing values. And there, if you remember, we learned either you can use the mean or mode or median, or you can use the forward fill or backward fill based on if you have time series data or you have a constant data. So those type of things here not required, so I'm not doing at the moment. Now the target column for is the churn. This is our target column because whatever analysis we want to do, whatever modeling we want to do, we want to focus around the how many customers are getting churned, how many customers are not using this service after certain point of time. So this is our target column in which we have two categories and we are getting some values of 0.50 and 440. Okay, so these are the column. Now this was the step where we explored about the dataset. Now we need to define our features and the target. So from the complete dataset, from this is 14 columns are there. We have already defined our target is churned. So now remaining whatever is there is our feature, because we have already dropped the column name customer ID, which was not at an informative, and we don't want to include in the modeling section. So this part is very very important, section 3, where you define the features, you define the targets. So once you will define the feature, so let's say you are defining the features, all features. So x is df dot drop dot churn, means you are dropping this churn data set, and remaining whatever it is, it's the features. So that means like out of 13 columns, you will have here 12 columns which are there in the x, which are there in the feature dataset. And the by, what is your target is the churn. Now you can quickly print it, you know. So you can see the shape of the x and shape of the y. What do you think what will be the shape of the y, and what do you think what will be the shape of x? Can I ask you this question? So take a pause and think and decide. Shape, we are talking about the instances and column. So in the x, we will have all the column except churned, and we'll have total instances of 5000. However, in the by, we'll have only one column, but we'll have all the instances, total 5000. Okay, let me run it. So what you are getting? You're getting x shape is 5000 into 12 columns, and in the shape of by is 5000 instances. So that means it has only one column, and that is a target column. So before going to the modeling, when you inspect your complete data, you need to decide what is your target. Your target can be anything. When you are working with the medical data sets or like the hospital data set, it can be responder, non-responder, it can be a patient who are getting benefit from the treatment or not getting benefit from the treatment. It can be anything. It depends on the objective of a study, of your study. So you decide your target first, that what kind of predictions you would like to make, that is your target, and then you will use the features that will help you to make those predictions better. So that's how you define. Now, once you have defined your metrics, once you have defined your target, then it comes to the another section, which is section 4, and that is splitting the data into the train and test set. This is again very important section, because in most of the cases when you have a real test data set where you would like to check the accuracy of your model, before that you would like to check the accuracy of your model on your own test data set. And that's a good platform to start, where you know about your model, how much accurate, how much sensitive, how much specific your model is. So for that you can do a splitting based on how much splitting you want to do. Like right now what we are doing is, so we have X, which is, we have already seen 5000 instances in 12 columns, and we have Y, which is a response column. What we are doing is split test train, 80 train and 20 test. So test size is 0.2, means like out of 5000 instances, 1000 instances will go in the test, and 4000 instances, remaining 80%, will go into the train. Okay, and we are doing this by randomly and stratifying based on the response target by, so that we will have a balance. So this point is very important. If you will not do stratify by, and if you will run it, so you will randomly get 4000 in the training and 1000 in the test, but it might not represent, or like might not present the equal type of distribution of the targets. What if in all 1000 test set you are getting all the one type of targets? So it is not good for the prediction. Okay, so stratification is important to keep the balance of your target response in the training and test dataset equally, almost equally. You can change this thing to 70/30, 70/30. It's up to you. I will quickly show it to you. So right now when I'm doing this, so what I'm getting out of train, I'm getting train, the feature set train, and then I'm getting the feature set test, then I'm getting target for train and target for test. So ultimately I was having X, so X I'm dividing into train and test, so which is 80 and 20, and then by I'm dividing train and test, which is 80 and 20. So now we were seeing the split of X or Y. Now we'll see further two splits of X and two splits of Y: X train, X test, by train, by test. And this we'll use for the training. Now, again, check the distribution, check the shape of X train, X test, by train, and by test. Okay. Once we'll do this in the training set, obviously, training set we have 4000 instances, 12 columns. In the test, we have 1000 instances and 12 columns. And in the target distribution, again, we have for the churn data, which is our target distribution in the train and test set. Okay. Now, so far what we have learned, we have downloaded the data, we have imported the data, we have checked the missing values, we have checked the data exploration in on such a way, do we need the imputation or not. We decided we would like to move forward with all the columns, we don't want to do the imputation because we don't have the missing values. We just removed the customer ID column, we defined our target, we defined our feature set. So almost everything is ready for the modeling. The only thing is, we would like to see how many numerical column we have and how many categorical column we have. So from this data set, you can define, you can check, because you have already here. Like these are the categorical variable, these are numerical variable, categorical variable, numerical variable. So you can go here, and this is what we are doing for the cleaning purposes. So you can define here and you can define numerical features. You can put all the features which are in numerical: age, watch hours, last login days, monthly fee, number of profiles, average watch time per day. And same you can define the categorical variable. Okay, once you define the numerical variable, categorical variable, you can print all the numerical and categorical variables. So here are your oh, it's where I am, sorry, here we are. Okay, so once we do this, so we have total numerical columns, we have categorical column. Why we are doing this? In case in case if we need any kind of encoding, in case if you would like to not use the categorical column in the modeling, in case we would like to only use the numerical column for the modeling. So we'll have this information, like we can just subset our data frame just getting the numerical column, numerical features, or just getting the categorical features, and we can use them accordingly based on the modeling. Okay, now once we know our categorical feature, once we know our numerical feature, it's very important to do the pre-processing. Okay, pre-processing pipeline is very simple. In the pre-processing pipeline, what I'm doing is, if you remember, we can do the scaling. Scaling can be min max scaling that we learned in the data pre-processing. Pre-processing can be standard scaling. In this scaling, we can only tackle the numerical dataset. If you will put the standard scaling on the categorical dataset, it won't make any sense, because the purpose of the normalization is to distribute your data, let's say from 0 to 1 if you are doing min max. So the numerical values which are going like very high or very low in the range, you take them in the range where you can use them for the comparison for the modeling. So we are doing numeric transformer. So for the numerical values, we will use the numeric transformer to convert them into the scaling values. And for the categorical one, we are doing the one hot code encoder. If you remember from our pre-processing part, we mentioned this one hot code encoder, in which we will assign numbers to the categorical values. Okay, so that's how we have a categorical transformation, we have numerical transformation. Now if you remember, we have numerical feature, we have categorical features. Okay, so we are using the numerical transformation and we are using the categorical transformation, and we are converting it into the single pre-processor. So this pre-processor will process all the variables that we have, categorical and numerical, separately, and will transform it. So if we will run it, so this means like preprocessor created successfully. Now preprocessor is selected, created successfully. Now we can build the model pipeline. So in the model pipeline, we are providing the preprocessor information that we have, that okay, we have some categorical variable, do the standard scaling on that. We have some categorical variable, do the one hot encoding on them. Okay, and now we are defining our classification, the model that we would like to build. So here, let's say the classifier or the model that we would like to build is the logistic regression. There are normal regression, linear regression, logistic regression. You will learn about it. Linear regression, when you are trying to understand the relation between only two features at a time. Then linear regression work. In the logistic regression, you can include multiple features, trying to find out the relationship of multiple features with the output variable or with the target variable. Here for us, the target variable is the churn, and other features that you would like to identify the association, that are all, that are age, watch hours, last login days, monthly fees, predictive profiles, numerical columns. We have gender, subscription type. All these features, you would like to see the association of these features with the target variable, like churned information that is available in the Netflix data. Okay, so for this model, we are doing the maximum iteration of 100. You can do maximum iteration of 1000. You can do maximum iteration of 10,000. As much as iterations you do, the time the model will take to compute the things will be higher. But at the same time, the accuracy of the model, the consistency of model will be also higher. So you can define your iterations and everything. So here we are doing the pipeline with the preprocessor and with the logistic regression, and here we can say the pipeline is ready. Now you are doing the model fitting. So what is model fitting? So in the model fitting, we have this pipeline ready, in which we are doing the pre-processing and then logistic regression. And on what we are doing is X train and Y train. So if you remember, we have the data set. So we have the data set of, let's say, X was our training data set, X, and Y was our target variable. Okay, Y was our target variable, and this was our feature set. Okay, from here we divided to X train and X test. So this X test was for us for testing purposes, because for this X test we know the feature, we know the response also, and this by target was, again we set like Y train and Y test. So why this is important, text and train thing is important, that we did previously, because for X train And by train we will train the model using xtrain and by train. We know the instances, we know the response, we know the instances, we know the response, we know the instances, we know the response. Then we'll use x test for the prediction. We'll pass this x test through the model and we'll predict the by values. So what we'll get when we'll pass this, we'll get by pred. And for by pred, like responses we'll get, we already have the x by test. So we have the real values and we have the predicted values. Using the predicted values and using the real values, we will compute, okay, the prediction that we are making is true or false. And here we compute the accuracy specificity. I will explain it to you. But I hope you understand why this training test splitting, why this training using the X train and Y train is extremely important. If we'll do the model fit, so this is our simple model. The pipeline is here, preprocessor, which is column transformation. Numerical column, we are doing standard scaling. Okay, you can check a standard scaling function. On the hot encoding categorical column, we are doing one hot encoder function. Okay, and then we are building the logistic regression. So this is our complete pipeline. We can simply do this model training completely successful. We can do this also. Okay, so now, so far, if we quickly recap, the data is there, imputation was not needed, we explored the data fully, we removed the category, we removed the customer ID, we took out the categorical numerical column, we defined the functions to normalize the categorical columns differently, numerical differently, and then we define our logistic regression models with number of iterations. So far everything is ready, model is ready, and model is pre-fitted on the training dataset. Now model predictions, it's very important. For the model predictions, if you remember, now our model is ready. Now this model can predict the responses on the X test. X test is a remaining test data, 20% of the dataset that we haven't used in the training. So here we'll get the predictions by predictions, or we can get the prediction probabilities. So this prediction varies. It's up to you how you would like to make those predictions. Like if your response variable is, let's say, a target variable, you are trying to find out, there will be some churned, there will be churned yes or no. Let's say if there is some disease, yes or no, there is anything, it can be binary information there, and you would like to make the predictions. So the predictions will be yes or no always, or you can get the probability. So probability, like from 0 to 1, it will give you the response of, let's say, yes, but the probability is, let's say, 0.6, 0.7, 0.8, 0.5, 0.4. So there you can define the threshold, that beyond this threshold you will consider this response that is coming is high confidence score. So those things we'll learn. But right now both things are important, because using the probability, it is easier to define the threshold, it is easier to consider some of the predictions and to not consider some of the predictions. So let's say on the text dataset, if you remember, we were having 1000 total, 1000 instances. If you'll make the predictions and if you will use the probabilities, and you will say a strict threshold of probability, if the probability value is not greater than this, then don't make any predictions. So you can make here predictions for 800 instances, not for 200, but so by using the probability information, you can decide how strict you would like to be. Okay, so the probabilities you can get and predictions you can get. So simply, if you'll see the predictions, how you will look like. So the sample predictions you are getting for churn, the predictions you will get 0 1 0 1 0 1 0 1, yes no, yes no, yes no, yes no, okay, whatever the response is. But in the probabilities, you will get some probability values. Here you are getting probability values, which can be ranging from 0 to 0.0 to 1, or like 0.0, 0.0 to 1, something like that. And these probabilities tells you that what are the chances strongly to for the prediction that we are making is to be true. So this probability can be used, as I mentioned. So here you will get the prediction for all 1000, and here you can define that you can reject some of the predictions, and you can make, you would like to make predictions only on 800 instances or 700 instances or 600 instances, which have a probability value higher than this, to make sure whatever results you are getting are more confident and more accurate. So you can use both, like direct predictions and the prediction probabilities based on your requirements. Okay, now this is very important. Now the classification report. If you remember when we discussed about by test, so what is by test? by test is the actual level. By test is the actual level. 20% of the data that we stored is the actual level. Okay, churn data. This we know, but we haven't used this by test in any of the models so far. Okay, because for by test we have a X test, the features. X test we passed through the model to make the predictions, and the predictions were bipred. So these are our predictions, and these are our actual levels. Now we can see the classification report. Okay, so when we'll see the classification report, so we'll get something like this. So this is our classification report. For 0 and 1, we know the precision, we know the recall, we know the F score, we know the support. 0 is one category, 1 is another category. Okay, that is yes or no in the churn category. Okay, so this is our overall classification report. Macro average accuracies, weighted averages, everything is here. Okay, now it is very important to know about the confusion matrix, and confusion matrix is extremely important thing for by test. If I will ask you few questions here, okay, I will ask you by test, the level of y test. Let me put it like this: y test and bipred. What I will ask, that level of bipred was 1 and predicted bipred is also 1. Is it true positive or false positive? So you will say it is true positive. What if I will say the level for by test was 1, okay, but predicted was 0? Okay, so it is what it is. Or like test for by test was 0 and predicted was 0, so it can be true negative also, if we are considering the 1 as a positive and 0 as a negative. Okay, true negative because it was a 0, or negative if one we are considering as a positive. Okay, if 0 we are considering as a negative. This is our variable, we can define whatever we want. So if the actual level was 1 and predicted level was 1, then it is a true positive. Actual level was 0 and predicted level was 0, then it is a true negative. Now actual level was 0 but the predicted level was 1, then this is false positive. This is false positive. It's very important. What if the actual level was 1 but predicted level was 0? Then this is a false negative. And this is extremely important for you when you are doing any kind of modeling exercise. Extremely important. Once you understand this, false positive, true positive, false negative, and this is called confusion. This is called confusion matrix. By using this, true positive, false positive, true negative, false negative, you compute all the measures. You compute sensitivity, you compute specificity, you compute accuracy, ROC, AUC, everything that you can think of that will evaluate the performance of the model. Okay, so this is how the confusion matrix is. So confusion matrix is the CM. We are just making a plot in terms of heat map. You can just print it also. So here is the confusion matrix for you. Let me make it a little smaller just to show it to you. So confusion matrix, this is your actual level and this is your predictive level. What I showed it to you. Whatever, let's say, is right now, whatever you will do here, you can do true positive this, true negative this. I just took the example of 1 as a positive and 0 as a negative. You can take whatever you want. Actual level was 0, predicted level was 0. So true positive. Actual level was, let's say, 0 and predicted level was 1. False positive. Actual level was 1, predicted level was 0. False negative. Actual level was 1 and predicted level was 1. True negative. So these are the values that you can present in form of anything. This is your confusion matrix, CM. So confusion matrix, you can see the numbers also here. I just plotted true positive, false positive, true negative, false negative. So you can use these numbers to do any kind of evaluation of your model. So this is extremely important whenever you are validating the accuracy of the model on the test data set. Make a confusion matrix, do all type of evaluation, performance evaluation, and then decide how your model is working. Then this model will be used on the real test dataset. On the real test dataset, you cannot compute the confusion matrix because on the real test, you don't know the predictions. You want to make the prediction. So that's why the train test split that we learned here, is extremely important, because in 10 test train split, you are using the test data set. For that, you know the predictions already, and now you are making the predictions. And by knowing actual levels and the predicted levels, you can compare it and check the model's performance. So that's how it's very, very important. I hope you got my point, why training and test data set is important, because to compute the confusion matrix, to compute the accuracy, to compute the performance, overall performance of the model. Now, now you can go to the ROC curve. For ROC curve, again, you will use two information. First, by test. What is by test? Is our actual level. By probability. What is by probability? Is the probability value that we have predicted. Not the actual prediction, but the probability values. Okay. Now, AUC score, you can get the ROC AUC score using the by test and the probability, predicted probability that we did. And then you plot the figure, PLT figure size you can define. You can define FPR, false positive rate on the x-axis, TPR, true positive rate, and then you can define AUC score. Then you can so plot ranges. What is X level is a false positive rate. What is Y level is a true positive rate. Plot title is ROC curve, lesion. So these things you can change as much as you want. You can change the colors, play with the figure as much as you want. This is a data visualization. Visualization, we are coming in the next module. We'll learn each and every type of visualization in detail. You can play with the visualization as much as you want, but here the purpose is just to show you the ROC curve that you will get with the thresholds using the probability value. So if you remember, when we were getting this, the probabilities, so we were getting the predictions that we have recently used, and we are getting the probabilities. Okay, so the predictions we have used for confusion matrix, but probabilities we are using for the ROC curve and to getting the thresholds, because here we are making the predictions, either the prediction is 0 or the 1. We are not making any probability, but here we are getting the probabilities of what is the probability or chances of getting 0, what are the probability of chances getting 1. So here we can define the strict thresholds also that we discussed. So that's how you are getting in the confusion matrix. So if I'll run this command, I'll get ROC of something like that. So AUC is 0.96. So this is a false positive rate, this is a true positive rate. You need to find a sweet spot where your false positive rate is less and the true positive rate is high. So which is somewhere around here, where you have like true positive rate of around 0.9, 0.95, and your false positive rate is like 0.1 or 0.2. So this can be your sweet spot. So here ROC curves help you to decide and defines the model's accuracy. If I will select this model, if I will use this threshold, this will give me like at true positive rate, like true predictions of 95% of the accuracy, while false prediction of around 5 to 10% of the times, you know. So this is very, very important for you. Now after this, once you train the model, logistic regression, or now try playing with all the type of modeling you can here. This is just an example of logistic regression. You can try any machine learning you want. Try decision trees, try SVM, try random forest, try linear regression, try whatever you want to do. Explore this model building pipeline in detail. See how you can use different kind of machine learning based models here. Now the idea can be for you, make different type of model 1 for logistic regression, model 2 for something else, model 3 for something else, model 4 for something else, model 5 for something else. Then compare the ROCs. Let's say the ROCs we are getting at the end, compare the ROCs and make simple table or figure in which you will say, okay, the ROC comparison of different models you created on the Netflix churn dataset to predict the churn level. Okay, easily it will be quick, and it will be quickly easy to see which model is performing better, which machine learning based method is performing better on prediction the churn rate utilizing the Netflix churn dataset. So this is a very simple task for you guys, but try it, do it, prepare multiple models, compare the performances of the multiple models, and finalize which model is working best on this particular dataset. This can be a take home exercise for you guys. Now, after the ROC curve, it's a model optimization. So in the model optimization, you can select the grid, you can select the classification solver also, and in the grid search, you can take the model and you can search the grid for CV5 fold cross validation, and you are doing the accuracies. Okay, So now this particular part is just to find out the grade, dividing the complete data set into the multiple folds. There are some warnings that I'm getting. So here is the cross validation accuracy, which is 89. So what I'm doing right now, let me explain this to you very briefly. Okay, why I am doing this? Let's say the cross validation accuracy that I'm trying to solve here is, if you remember, we were having a data set of x and y. X was the training for us. X was the feature set for us, feature set that we'll use, and y was the target for us. Okay, and we randomly selected 80 and 20% split, 80% and 20% split, by which we are getting x train and x test. Okay, by train and by test. This is what we were getting. So this x train, by train we use for the training, x train we use for the predictions, for making the predictions, by which we got the y pred or by probability. This is what we got. Okay, by probability we got, and this by pred we used with the by test, which is original and actual level, to make the confusion matrix. By probabilities we used with the by test to make the ROC curve, AUC curve, and to get the different measures. So this is the overall story that we did. Now in cross validation, which is extremely important, now what you do is, instead of, you're doing the same, let's say 80-20% split you are doing, but what you are doing is, your complete data set you are dividing in 5 parts. Okay, 5 parts. So this 5 part can be, now your, it was your x and y train. Let's say x data set was having, so x part you divide into x1, x2, x3, x4 and x5. Now in the cross validation you are using first 4 for the training and x5 for testing. Then you will do these 4 for testing and this training and this one for testing. Then remaining 4, so you will use all the 5 set for testing one time. When you will use this for the testing, remaining will be the for in the training. When you will use this for the testing, remaining one will be in the training. When you will use this one for testing, remaining one will be the training. When you will use this for testing, remaining one in the training. So this is called cross validation. Sometimes when you report cross validation, in this the beauty is, you have checked the performance of all the data set one by one. So the model is not biased towards the 20% of the split. What if we are getting randomly most of the accurate data in test set, then the performance of model will be higher, and then model can be biased, because when we'll see the random another data set, on that the performance can be lower. So ultimately, by using the random split of 80-20, sometimes we might not get the overall or in general accuracy of the complete data set. So the cross validation is a very good part in which you are utilizing the all data in the test set some or one other point of time. And specifically you are doing like this, you can do complete data validation, cross validation 5 folds, you can do cross validation 10 folds. Okay, so ultimately the purpose is, divide the complete data into those many parts, consider one part for testing, rest for training, one for testing, rest for training, one for testing, rest for training. Do it till you will utilize all the parts for the testing purposes. So that's how you get the cross validation performances, or that's how you get the performance on the cross validation. So here you're getting, let's say, grid search completed, and the best parameter you are getting is classifier C. Classifier solver is a live linear, and the best cross validation accuracy is 0.89. So for this model, I can confidently say that my accuracy is 89%, because I have checked this on the cross validation also. I hope I explained this to you nicely. You can read about cross validation as much as you want. This is a very important aspects of performance measure. Whenever you will report your model's performance to anyone, you will say your ROC, AUC and performance or accuracy is this. They will ask whether it was tested on cross-validation dataset or internal test split dataset or on the real dataset. So you need to report it. It is on the cross-validation or on the real dataset. That's how you can report the performance. So it's very, very important. Okay. Try it, learn it as much as you can. Now, evaluate the tune model. Now, from the grid search, we can get the best model. From the grid search, we said that our classifier is this, best solver is this, but from the grid search, you can get your best model. On the best model, you can again make the predictions. On the rest data set, final pads. These final pads, again, you can get the classification reports and the confusion metrics that we discussed. We are not making the ROC curve. If you will make the ROC curve, then you know what you want here. From the model predict, you will get the model predict something, model predict probabilities. Remember? So right now we are getting the final models. If you want to get the final props instead of predictions, you will like to get the probabilities. So you will get the best model predict probabilities, but right now we don't need it. So you know when we need the probabilities, when we don't need the probabilities. Right now we are just making the confusion metrics. For confusion metrics, we need a true and false or yes or no labels. In the predictions, we'll get yes or no labels. In the by test, we have the original yes or no labels that we have already seen. So by this, you can easily make the confusion matrix. So here we are simply making confusion matrix. So on the grid search, we are getting the best model. From the best model, we are making the prediction on the test dataset. From the test dataset, we are getting the final predictions. And these are our final predictions, and these are our actual levels. These are our actual level of by test, which we stored to check the performances. So that's how you are getting the confusion matrix. So this is the accuracy, precision, sensitivity, everything you're getting. And this is again your true positive, false positive, true negative, false negative. Now you can learn here all the formulas of sensitivity, specificity, recall, precision, recall, and everything. CC, AUC, read about it, like what is sensitivity, what is specificity. Now when I ask you in your model that you want to finally present, what do you want highly specific model or highly sensitive model? Those are the questions that will come from your side. Sensitive is when you are saying you are making most of the prediction, you're getting 100 instances and you are making 100 predictions. That means your model is 100% sensitive. Now at the same time, specific, so you will ask, how out of 100 predictions, how many true predictions you are making? That is specificity of the model. So you need to find a proper balance between sensitivity and specificity, and that is somehow is the ROC curve is. You can be little less sensitive, but you want to be more specific depending upon the situations, depending upon the projects, depending upon the problem that you are working on. There are certain problems in which you would like to be 100% sensitive. You can't miss any of the instances in which the negative or the missed instances can have a larger effects. So those are the things that you can decide. But I would like highly recommend you guys to learn about these things, these evaluation matrices: sensitivity, specificity, recall, precision, everything. How can you can use the true, positive, false, negative to compute those matrices? What are those formulas? How you should find the balance between sensitivity, specificity, in what conditions you need higher sensitive model, or in what conditions you need higher specific models. Learn about those things. Then definitely I would like you to go here at the model and use, instead of logistic regression, try to use other machine learning models also. Label those models, use like 10 to 15 different type of models, different type of machine learning based models. Label those models, get the performances, AUC, ROC, confusion metrics, compare those performances across models, and come up with the best model that is performing the best churn rate prediction on this particular data set. So that can be your solid exercise to learn, to practice as much as modeling you can. You can start working on the different data set also in which there are some missing values. You can add additional steps of handling missing values differently. Try, so you can take a data set in which some missing values are there, impute them, fit the model, make the prediction. Don't do any imputation, fit the model, make the prediction, check whether imputation is working or not, compare performances and say, okay, imputation is working and the model performance is increasing on this dataset. Those kind of things you can do here, like n number of projects on n number of datasets. Just go to Kaggle, download the dataset, define your objective, and complete end-to-end advanced data analytics project. You cannot get the best guide what we have than this what we have discussed today. Okay, I hope you enjoyed this session and you will practice each and everything we have discussed, like the models recap, everything, data exploration, defining model, defining column types, pre-processing, building model pipeline. So like the most of the things we have discussed here, data pre-processing specifically, train test split, pipeline creation, model training, evaluation performance, specifically accuracy, confusion metrics, ROC, AUC curve, optimization with grid search. Okay, always encapsulate your process into functions or pipeline for reproducibility. Whenever you are making those kind of models, try to make the functions that we made for our logistic regression. So that's how you can call that function and again, and it help you to get the reproducible result. It helps you to get the results that you can easily compare with the other approaches. Okay, now the take home message for you guys is, go to the model evaluation deep dive. Apart from logistic, explore as much as models, other models, try other models, other ML models. Okay, this you need to try some feature engineering technique on real world data. Go to Kaggle, download different data sets, try feature engineering, lot of feature engineering. Do we need to remove some features? Do we need to do the imputation if there are missing values in this data set? There was not. Then feature engineering, like do you need to combine two or three features together to make a separate feature which is more informative than the individual features? Those kind of engineering you can do. Optimize and select the best model in the practice. So whenever you will do the project, I would recommend you to take a data set, define your objective, like you would like to make the prediction of something, then define that you would like to compare different machine learning based models, and there do all the feature engineering, all the model deep dive, all different kind of machine learning, create a performance report, model performance report, and make a conclusion at the end that you have created a model, the best model that can make the best prediction on this data set by doing these things, and that can be a report. Push that on your GitHub, and that's how you show that you can do the advanced data analytics and all those things. Apart from this, if you want to learn a little bit about the model explainability, then read about feature importance, read about SAP, Lime, those kind of values. Those are best practices for deploying the analytical methods. I'm not explaining this here, but in the additional video section, you will find a short videos in which I'm explaining confusion metrics, I'm explaining feature importance, because out of all those 12, 13 variables, which are all are not equally important in making the predictions, so you need to identify which feature is the extremely important or the most important in making the predictions. So those kind of things you can do by the sub values, feature importance, and in the additional section you will find the short videos for all these topics. I hope you enjoyed this session. I hope you will practice it as much as you can, and then I will see you in the next module in which we'll learn about the data visualization techniques. We'll go deep dive in each and every details of data visualization using Python. See you soon. Hello and welcome to the module 5.6, which is all about data visualization. So far what we have learned is getting started with the Python to set up your environment, to download and import all the libraries which you need for the data analysis. Either you're working in Jupyter notebook or you're working in Google Colab. Everything is set in the first module. In the second module, we discussed how to import and explore the data. Then we learned about data cleaning and pre-processing strategies. After that, we learned how to do the statistical analysis in Python. Then we discussed about the advanced data analytics techniques. And now the most important part, the module 5.6, which is all about data visualization. Data visualization is a very important and key skill, because whatever analysis you will do from start to end, ultimately what you will show to the stockholders, what you will show to the collaborators, what you will show to any other team members is the plots, is the graphs, is the chart in the form of the visualization. And there your visualization, your plot should convey all the story behind the data. So that's why data visualization is critical. If you will master this particular step, then you know how to present the key insights that you have find from the data. Data visualization helps anyone to make data driven decisions. So this is very important step. You need to learn each and everything, what kind of visualization plots you can make depending upon the data, how to first learn about the data set and then decide which visualization plot will work best based on the questions that you have in that particular project. So in the data visualization, what you will learn mainly is to first understand the purpose of data and visualization in the analytics. Then we'll learn about the libraries like matplotlib for the basic plots like line plot, bar plot, histogram, and scatter plots. And you will understand when you need bar plot, when you need histogram, when you need a scatter plot. These things are very important to learn. And then we'll use Seaborn for beautiful statistical visualizations like box plots, violin plots, heat maps again, and the pair plots sometimes when you're considering multiple variables at a time. At last, we will explore a little bit about the Plotly. So Plotly is another library which gives you the flexibility to create the interactive dashboards or interactive plots. So these interactive plots sometimes very useful when you would like to keep track of the data, how the data is changing. So we'll learn about this also. So ultimately, selecting the right visualization type is the right way or the right kind of telling the data story. So I hope you guys are ready. We'll directly go to the code base, and there we will start learning from the data that we were using in the previous module also. So if we'll go to our code base, we'll go to the data visualization part, which is module 5.6. In this, like, we'll learn little bit the concepts of the data visualization. Specifically, the purpose of this is to explore, explain, and communicate the data insights. This actually data visualization actually help us to identify the patterns, trends, and outliers. There are multiple layers for the data visualization. If I'll do, first layer is the univariate layer. Univariate is very simple, it's clear from the name, in which you are considering one variable at a time. So for one variable, you can go for the distribution. You can check how that particular variable is distributed across the data set, and you can make any decision by doing the univariate analysis for one variable at a time. Then bivariate, again, it is simple and clear by the name. It's when you are considering two variables at a time in for the visualization. So here you can understand the relationship between two variables. This is very very important when you want to try, you are interested in identifying the relationship between any of the two variables. Like if we are working with the Netflix customer churn data set, if you want to identify the relationship between the age and churn ratio or churn rate, if you want to identify the relationship between the premium fees that are used and the churn ratio, so those kind of relationship you can explain or you can explore based on the data set you are working with. The third type is multivariate, again clear from the name, in which you have multiple variables, more than two or three variables, uh, to find out the complex insights. When you have multiple variables, so in most of the analytics projects, you are not expecting that you are getting only one variable or two variable. You can have n number of variables, sometimes hundreds, sometimes thousands. So it is important to identify the important variables. It is important to identify the understand the complex relationship between the variables. So multivariate analysis help us to uh, deal with the multiple variables at the same time. Okay, we'll start from the same. We'll load the libraries import.pandas as a pd, matplotlib as a plt, and seaborn as a sns. If you don't have these libraries, go pip install any of the libraries that you would like to install. I'm not installing it because I have already ready these libraries. You know, I have already explained pandas here is for the data manipulation mainly, matplotlib is for the basic plots, and seaborn we will use for the advanced and more aesthetic plots. You can set the display like sns set. You can set the plot size, figure size. These things are very customizable. You can change it whatever in such a way you want. Okay, then you will load the dataset. Now if you remember, this is a Netflix customer churn data that I have already shown it to you, like how you can download this dataset using the Kaggle hub. Importing Kaggle hub library, you can download this dataset. I have shown this in the module 5.2. You can go back and see. If you are following the modules, if you are practicing the module, this data should be in your working directory, so you can directly load it like I have in my working directory. If I will simply hit the button, I will get the df head, the first five lines of this dataset, which is first five rows 0 1 2 3 4 5. I have different columns: custom id, age, gender, subscription type, watch hour, last login days, and some. I have multiple columns for this. We can quickly check the info, like how many columns I have and the categories of the column. So this is a quick glance that you should always do. In the quick glance, First is the info command, df info. What it will do is it will take each variable at a time. It will take the variable, let's say watch hours. It will try to identify how many null values are there, and describe command will quickly compute all these statistics, like mean, mode, median, percentile, 25 percentile, quartile, and 75% quartile. Everything it will compute. And when we are saying include all, it will do for all variables. If you will not select this include all, means you will compute the describe function for only for the numerical variables. Okay, when I will run this button, you know how many entries you have. Total 5000 entries from 0 to 4999. You have total 14 columns from customer id till the favorite genre. How many non-null values you have in each column? You don't have any non-null values, that means you don't have any missing values, so you don't need any kind of imputation specifically in this dataset. Then you know about each column, the data type. You have object, integer, float. Integer, like you have a strings or integers or float values, like categorical values which terms as a string you need to convert into the numerical if you need them for the visualization or for the modeling somehow, so you can convert them. Okay, and this is the quick statistics. Like for each column you have a quick statistics like mean, standard deviation, mean, 25% quartile, 50% quartile, 75% of quartile, for subscription type, for watch hours, for last login days. So this is what we are doing. There are some categorical and there are some numerical variables. For categorical variables, you will not get the mean, mode, median, this information. For numerical variable you will get all these information: mean, mode, median, standard deviation, and those things. So for quick inspection of the dataset, it's always recommended to use the info command and to use the describe command. These two commands help you. Now, the first thing, if you remember, we discussed about the univariate analysis. That means we are trying to explore one variable at a time. And here specifically, we are interested in looking the distribution of that particular variable. Now, df is our data frame. We are exploring the age part. We are doing the bins, 20 bins, and we are putting the color of sky blue, and we are writing the title name as age distribution for the Netflix user. What is the age distribution? Are there the young user? Are there like middle age users, or there are old users? We can quickly get the distribution based on the age for the complete dataset. So this is a quick histogram, and in the histogram you will see this. Here on the y-axis you are getting the count, on the x-axis we are getting the age, and age is divided into the multiple bins here, no, in the bins. So here you can see that the age distribution is not directly associated, or like age is not directly associated with the high user count. There are all number of ages present. Initially you can see like at the age of 20 there are 300 users, at the age of 60 or 70 also there are 300 users. So you get a quick distribution of the data. And here by using the histogram you can check the distribution is normal distribution, like following a particular trend, or this is a skewed distribution. When you get this skewed distribution, that means if you're getting the initial age, like young age are using a lot, the count is higher, and the old age have a count of lower count, then you will see the left skewed data. You can see the right skewed of the data also. And this help you how to utilize this data for modeling purposes. Do you need some kind of normalization before using this data? So those kind of information you can get for any variable you are interested in. For instance, here we are looking at the age at the moment. If we are looking for let's say for the numerical columns only, so let's say watch hour is the one that you would like to explore, the distribution, how much is the distribution of watch hours. So you can put the watch hours here. You can change the plot title. Now watch hour distribution, watch hours distribution of Netflix user, and you can quickly hit the button. So here you can see quickly the watch hour count is, so mostly the watch hour is in between 0 to 20 hours. So the maximum count you are getting at somewhere around this range, from 0 to 1 hour or 0 to 4 hours, something like. You can label it as much as you want. Right now we have done the labeling at the uh, interval of 20. So this histogram is clearly telling you the information about any variable that you want. You will quickly get an idea how your complete distribution looks like of total 5000 instances for age, for watch hours, for last login days, for region, device, monthly fee, even payment methods. Payment method is a categorical variable, so you cannot get it. Average watch time per day, you can quickly explore this also. So I always recommend, whenever you are working with the dataset, any kind of dataset, I always recommend that most of the numerical variable that you would like to use, let's say monthly fees. So again, we'll go and we'll put here the monthly fee just to check the histogram and distribution of the monthly fee, which is not at all, monthly fee is pretty much count is fixed based on the users those are using the dataset. So again, for you it is simple. You need to explore each and every variable in form of the histogram, and that will give you a great idea of the complete data set. So this is one way to looking at the data. The second is the categorical count plot. So the categorical means like the histogram is good for the numerical data, but in the histogram you cannot explore the distribution of, let's say, gender or distribution of any other variable which are categorical. So for that you can use the count plot. So count plot, we are using the complete data frame, we have set one palette, and we have done the gender distribution. If we'll simply run this for, so we can get the gender distribution. So in this complete data set you can quickly see the others which are not divided into any of the categories, and there is female gender. Looks like the count of female gender on the Netflix user is little or slightly higher than the male users. So you can get a quick distribution of the categorical variable in terms of the count. Any of the categorical variable you would like to see, how many churned and non-churned information is there, you can change churned. You can get the churn distribution also. So churned and non-churned, it's almost about equal distribution. Then you can get the, let's say, payment method, the count of the payment method, if there is any differences between the payment method count or not. But you need to just make sure that whatever variable you are exploring, change the titles, change the plot accordingly. Like, so payment methods, some are doing by the gift card, some are doing by the crypto, debit card, PayPal or credit card. But out of the count information that we have available for this, it seems like most of the users in this Netflix datasets are paying by the debit card. Although the difference is slight, very slight, I don't think there is any statistical difference, there is not huge difference between there. So like equal amount of payment method has been used by the multiple users. So you can explore any of the categorical value to check the quick distribution. So in the univariate analysis, one is the histogram for numerical values, one is the box plot, something like, or bar plot, which is good for the count plot, you can say, which is good for the categorical variables. The third is a box plot. So now in this we are getting all the information, but the box plots are good. Bar plots are good to get a quick estimate of the counts, but box plots are good when you would like to identify the outliers also, outliers which are not following the range. And if you remember, in one of the data cleaning and pre-processing module, we discussed in the detail how to detect the outliers. So for the outliers, what you are getting the mean values, you are getting 25% of quartile, you are getting the 75% of the quartile. And there is an interquartile range. Interquartile range is from 25 to 75. And then by using the interquartile range, you are defining the outliers, like what will be the value that you will consider as an outlier which is outside of the interquartile range, and those outliers you can remove from the data. So box plots are the good to detect the outliers. So in the box plot, what you can do is, in the subscription type, which is your x-axis, subscription type is the x-axis and monthly fee is your y-axis, and you can create a box plot of monthly fee by the subscription type. Is there any differences, are there any outliers? So you don't like find relationship a lot, you are not getting multiple values here, because monthly fee is a one value that you have, so you don't have the distribution here. We can check some other thing here instead of the monthly fee. What, let's try watch hours. Is there any subscription types, any relationship between the watch hours and the subscription type? So here, if we are doing the relationship between the subscription type and the watch hours, so what it seems like, premium members looks like they are slightly watching the content a little bit higher than the standard or basic, we can not directly say until we'll get the mean values here. And then you can see clearly there are a lot of outliers here. In basic there are outliers, in standard there are outliers, in premium there are outliers. So box plots are very good. They provide you the information where is the mean of your data, like most of the users belongs to at what range. Then you have a range of like 25% of the quartile and 75% of the quartile. And then you have a outside of the numbers, there are some users which are watching like way beyond than any other users you have in that particular group. So those outliers you treat, like you decide whether you would like to do some kind of normalization or you would like to remove those outliers, you don't want to consider them in the analysis. So this is a good way to start histogram, count plots, and the box plots for the univariate analysis. Explore each and every variable in this part. If you are dealing with the data in which, let's say, 50 variables are there, first divide how many categorical and numerical variables are there. For categorical variable, go for the count plots or box plots. For numerical variables, go for the histogram plots and explore it. Perfect. Another additional type of plots you can do is the violent plot, which is also we are doing between the subscription type and the watch hours. Instead of the box plots, you can use violent plots. They look sometimes great. That's the only thing. Apart from that, violent plot doesn't like generally provide most of the information unless you point out or unless you put the data points on the plot. You will not get the information in this plot, especially not get the information about the outliers. You can label the outliers also here. What are the instances or what are the users which are coming here or here in the plots. So in the Byland plots, again, you will use SNS Byland plot. On x-axis, you need subscription type. By you are plotting the watch hours from the data frames, and palette is muted. So these things you can change whatever you want to put on x-axis, whatever you want to put on y-axis, and you can easily create the violent plot here. Okay. Now, after the violent plot, we will go to the second part of the analysis. So first we discussed is the univariate in which like we are exploring one variable at a time. Then we'll go to the bivariate analysis in which like we are trying to understand the relationship between two variables at a time. So these two variables can be continuous variables like integer. These can two variables can be categorical variables. These two variables can be categorical and numerical variables. So depending upon the data type, there are different methods. There are different visualization strategies that you need to adapt. So for instance, if you have both continuous variable, what is the best plot that you will use? So in case of the continuous variable, the best plot that you should use is the scattered plot, because scattered plot is can quickly give you the information about not only about the relationship between two or variables, but how strong that relationship is. You can quickly check and validate. Okay. So let's say this is a scatter plot in which we are doing SNS scatter plot between watch hours and monthly fee. And the U we are using, the color we are using based on the churned. So churned is we have already converted this data into churned, 0 or 1, either the user is churned or not churned, yes or no information that is there. Based on that, and we are trying to understand the relationship between the watch hours and monthly fee in the scatter plot. It's not looking like the scatter plot because of the monthly fee is not varying a lot. It's pretty much constant. But what if we would like to see the relationship between, let's say, watch hours and age? Just trying it. Okay. So see, here is the, so let me change the axis. On the x-axis I'm putting the watch hour age, and by axis I'm putting the watch hours. If I will do like this, it seems like there is no perfect association in this scatter plot. There are some data point at the higher age. It seems like they used to watch a lot. But then there is one thing that I can see, the churn rate. If they are not churn, they are watching for maximum hours here. So those kind of information you can get. You can remove this u data, you like churned information from here if you just want to see the relationship between the age and watch hours, but don't want to put the color code. So here you can see still like pretty much constant for most of the data point. There are some data point in each age range which are watching than the normal in that particular age groups. So those can be considered as outlier. So you can decide whatever scatter plot you would like to do, but you can easily understand the relationship between two continuous variables by using the scatter plot. Okay, you can play with the plot titles, you can play with the axis, you can play with anything, the modifications you can do, n number of things you can do here in the SNS scatter plot. The second is the correlation heat map. So for this you can define from the df how many variables you would like to use for correlation. If you will do simply df.core, it will try to find out the correlation between all variables. Sometimes when you don't have the uh, all numerical variables, you will get the error here, because the correlation you can only compute between the numerical variables, not between the categorical variables. Okay, so there are n number of ways. Either you do the encoding that we discussed, convert your categorical data or categorical variables into the numerical variables, and then use the complete data frame for identifying the correlations. This is the one thing. Second thing, identify the features that you would like to use, only the numerical features. Subset your data frame, select those numerical variables, and on that data frame compute the correlation. Or you can directly define here, like age, watch hours, last login days, monthly fee, average watch time, number of profiles, and the churn. These are the features that you would like to use for the correlation, and you can create a quick heat map, sns.heatmap, using the correlation that you will get. Annotations is true, and the color code you can define. Plot title you can define, and the plot.show command will display the plot. So if you will write this, you are getting something like this. So here, how you will read this correlation plot? You read this correlation plot, the range is from +1 to minus. Plus is the strong correlation, positive correlation. Minus is the strong correlation and the negative correlation. So higher the number is, stronger the correlation is. Okay, but at the same time, if it is on positive side, that means it's a positive correlation. So positive correlation simply means when you are comparing two variables at a time, if one variable is increasing, the other variable is also increasing. For instance, how you will say, the for what circumstances you will get the value of +1, or like value of plus 0.8, plus 0.9. You will get in the circumstances where, let's say, age is increasing, the watch hour is also increasing strongly. So you will see something like a scatter plot, something like this. So it's a strong correlation. So age and watch hour will have a strong positive correlation. But what if I will say, if age is increasing, watch hour is decreasing? So you will get a strong negative correlation. So that's how you read this plot. So here, forget about this center line, because this is trying to identify the relationship between the same variable. So this is, let's say, between age and age. So there is no point. But the second is between age and watch hours. Is there any association? I don't think so. This is 0.03. Very, very, very big association. It's not at all strong. But between age and last login days, very weak correlation. Between age and monthly fee, very weak negative correlation. Between age and average watch time per day, very weak correlation. Between age and number of profiles, very weak correlation. So that means, like, age has a very weak correlation with any other variables that we are seeing. What is the main association between the strong associations that we are at least seeing? So I can see quickly few associations here. First is the last login days versus the churn rate. So the last login rate and churn rate, so that means churn rate is higher, obviously, when the last login date is little longer. Means somebody has not logged in at all, that means he's already churned. He is not at all using, he just stopped using the Netflix. He's not the active user. Obviously, pretty much obvious here, but it is showing the strong association around 0.47 in plus. Okay, then there is one more association that I can see here, is minus 0.48, which is a negative association, which is between the watch hour and churn rate. So that means if somebody is watching a lot, they are still an active user, and they haven't stopped using the Netflix. And that is also pretty much obvious. If they are active user, if they are watching for the long time, so they are still active. And then there are other correlations that you can find, like minus 0.34, minus 0.35, plus 0.35. Then there is one more here I can see, which is somewhere around, yeah, that's it. So by just looking at this, you can make the scatter plot between these two things, watch hour and churned. If you will make the relationship between, or you can make average watch time per day and watch hour, you can make the scatter plot for these two. Just let's quickly see how it looks like. Average watch time per day, so we are making this scattered plot now. So we will simply select the average watch time per day and go to the scatter plot. In the scatter plot we will write, ah, let me come down sometime. So in the scatter plot, what I'm doing now, average watch time per day and watch hours. So let's see how it looks like. So scatter plot, see there are some outliers here, but it seems average watch time is little bit of increasing with the watch hours. So that's why you are seeing here the positive associations. You can quickly check for each and everything that you want here. Let's say you want to see for last login days and the average watch time. So you can do for last login day, last login day versus watch time. Oh, so I think I have not written correctly. Last login days. It's not day, it's days. Last login days and watch hours. So you can get this scatter plot, something like this. So I'm not changing the title here. You need to change the title whenever you are changing the x-axis or y-axis. I'm just displaying it to you. So whatever you will get from this scatter plot, this heat map is quickly summarizing all the information together, the relationship between the variables, each and other variables. You quickly understand which variables are positively associated, which variables are negatively associated. So heat map is a quick correlation. Heat map is a quick way to explore the complete numerical data in your dataset. Okay, now there is a war plot, bar plot. So a scatter plot is for numerical versus numerical variable. Heat map is only for numerical variables, and bar plot is good for the categorical and numerical variables. Box plot is also good for categorical numerical variables, in which you can get the outlier information also. In the bar plot, you can define the x-axis. Let's say you would like to use the region. So there are different regions, and you in different regions you would like to see the churn rate, whether the churn rate is higher or lower in which region. You're using the data frame and you are doing the estimators. Make the plot title like churn rate by region, by label, x label, takes and plot. So if you'll do this, you can quickly see this is your data. So the churn rate is looks like higher in Europe, in Africa, and looks like sorry, in South America, and looks like lower, or I would say the lowest in the complete plot, which is lowest is in the Africa. So that means people are not leaving the Netflix in the Africa region, they are watching a lot. So these kind of analysis you can do for any variable of your interest. Let's say if you are doing this, the churn rate for the region you are doing, now the churn rate you can do for what other categorical variable you have. So for each and every categorical region, like I think subscription type, is there any relation? Subscription type. So there are subscription type. You have a subscription type: basic, standard, and premium. Most of the churn rate, most of the people who are not coming back to the Netflix, which are the premium members. So the basic members are continuously enjoying this. No, I sorry, I interpreted it wrong. So the churn rate is higher in the basic users, not in the standard or premium users. So these kind of information are really very good from the perspective of, like, if you would like to understand the customer's preferences, customer choices, and those help you to better design your product. So this is just one data set. You can do these kind of things for any kind of data sets. You can do for the sales type of data, marketing data, and any other data sets ever. So ultimately the bar plot is really useful. You can just check the relationship between the categorical and numerical variable by simply plotting the counts, by simply plotting the rate on the y-axis. On the x-axis you can use the categorical variable for that. Perfect. Then, so far we did the univariate. So in univariate, for numerical variable we learned about the histogram. For the categorical variable we learned about the count plots, bar plots. And for the categorical variable we learn about the box plot also, which helps us to identify the outliers. We learned about the violent plots also. In the y variate we learn about the first, we learn about the scatter plot, if we would like to find out the relationship between scatter versus scatter. Then there is a correlation heat map plot, if you would like to explore the correlation of all numerical variables. Then there is definitely a bar plot to identify the relationship between the categorical and numerical variable. Okay, these things you can change according to the data. These plots you can modify, you can change the titles, you can change the labels, you can change the colors, you can put the labels for the individual data points, you can put the labels for the mean, mode, median, standard deviation. You can even put the information about the statistics, whether this difference is statistically significant or not. N number of things you can do here to make your plot more informative, to more make your plot more visually appealing. Okay, it's up to you. Keep exploring. Then there is a multivariate visualization in which you want to find out the relationship across features. So the most commonly used function here is the pair plot function. So in pair plot, you can define multiple variables at a time, and in the multiple variables you can find out the relationship between, let's say I'm doing age, watch hours, monthly fee, and the churn. So you are getting the categories for the age here, you are getting for the watch hours, you are getting for the monthly fee, and this is all divided based on the churn, two categories. Okay, I'm not going for the churn rate, but this is the churn data that we have. So based on that, you can decide, you can see how your data is distributed, like watch hours are higher in the categories of the one which is not churned yet, watch hours are lesser in the people who are not coming back to the to the use again, monthly is pretty much constant, then the age is also pretty much constant, not much differences you can see. But by using the pair plot, you can understand and you can identify again the relationship between the multiple features of your interest. You can define what features you would like to use for the pair plot. This is a good way for quick visualization. Another is the multiple small plots. Like instead of making the pair plot across variables, you can make multiple small plots. So let's say facet grid is a one of the common function in the SNS Seaborn, in which you are doing your column is a reason, you are dividing this based on the churn, you are defining the height, column wrap, everything, and then you are making this plot for watch hours and for the average time. So what we are doing, we have a regions. Let's say we have a region of Africa, Europe, Asia, and Oceania, South America, North America. And in all these regions, we are trying to understand the relationship between the watch hours, which is on the x-axis, and the average watch time per day, which is on the y-axis. So we are trying to identify the relationship between, so we already tried to find out the relationship between these two, but now we are further dividing it to identify the relationship between these two in any specific region. So sometimes what happen when you are exploring the data, let's say you are exploring the complete data, you are trying to find out the relationship between the watch hours and the average watch time per day, but there is no strong association. But what if when you will go to the different regions, or you divide the data into further subcategories, you will find there are some regions in which there is not at all relation, but there are some regions in which there is some strong correlation, some weak correlation is there. So that help you to further subdivide the data to explore the relationship a little bit further. So that's how these kind of plots, facet grid plot, helps you a lot. You can make these kind of plot and explore the relationship. Like it seems like here specifically there is one outlier only in Europe. In Asia there is one outlier, there are a couple of outliers here. In Africa there is like not much correlation between, I don't see there is any strong correlation here. Here you can find little bit of the correlation, there are some outliers still in this category also, but you can explore this based on the facet grid. For anything that you want, you can divide this into the age categories, you can divide this into the rate, you can even divide into the subscription type. So how many subscription types we have? So for subscription types we can get, okay, so we have subscription type of basic, standard, and premium. In each subscription type, is there any association between watch hours and the average watch time per day? This is quick and easy, you can change whatever you want here. You just, the facet grid will give you the flexibility to further divide your data based on the category of your interest and then see the relationship between two variables. So this is a very good example of the visualization that you can use in any of the analysis. Then there is another plot called heat map by category. Now, if you remember what we were doing the correlations and heat map for only the numerical data. Here what we are doing heat map by category is we are creating a pivot table, values for the churn we are taking, index is subscription type, columns is based on the region, and we are using the mean values here. And when we are creating this kind of heat map, if you'll see, the heat map that we are getting is for the regions, which is regions on the x-axis, for the subscription type on the y-axis. We are trying to see, is there any association between the subscription type and any specific region? What do you think, what can be your output here? Definitely there, it might be seems like in the basic there is a strong association with the South America, and not much difference. In Europe also 0.63, in South America is also 0.63. I don't think there is much difference except in the premium category. In premium category, there are differences which can be seen, like in Africa there is less association between premium category and the Africa region, but there are high association in the North America in the premium region, or in the standard region is also little bit differences, but not in the basic. Basic is pretty much fixed. It is ranging from zero point 0.6 to 0.63. That is not much differences, but you can, by using this kind of commands, by using simple pivot table, by using the churn data and the subscription rate, you can quickly find out the association between the categorical features also, by in form of the heat map, which was not possible when we were computing the correlations. So here we are not computing the correlations. What we are doing instead, we are getting the pivot table, and we are just getting the counts in terms of the associations, not the direct correlations, because correlations we can get for the numerical data only. Now for the aesthetic customization and storytelling, this is also very very important. I was discussing about this. You can do whatever you want here. You can define the plot size, like height, weight. You can define the x-axis, y-axis. You can define the use what you want, like here for us it's a churned. You can define the palette, you can change the color. Right now we are changing plot title, rotation. This rotation is sometimes very very important, because when you are writing this, if these names are big, they overlaps here, so it's always recommended to use the rotation of 45. So that's how you will get more flexibility here to get your x-axis title. If they are longer also, they will not be overlapped. Okay, you can fix the label x-axis, y-axis. You can write the fixed lease and watch hours by genre and churn rate. Then you can do the tight layouts and plots. So these are the things very flexible. You can play with it to make your plot very very, you know, useful, to make your plot visually appealing. You can play here with the colors, you can play with here whatever you want to put here. So ultimately what we are doing is favorite genre is action, sci-fi, drama, horror, romance, comedy, and then we are doing the average watch hours. So you will quickly see, so most of the average watch hour churned is still the pretty much fixed. It's not like churn rate is not at all associated with the genre that they are watching. It's pretty much fixed and contact, not much differences. But still, if you'll do some statistical calculations, you might see some of the differences, but I don't think there is any association between the genre that they are watching and the churn status, whether they are stopped using or they are actively watching. But you can explore this for any other variables, not for the watch hours or favorite genre, but you can use the reasons here. You can use the watch hours. Is there any association between the regions? Just I'm curious and would like to check. So in the regions also, I don't think so there is any association. It's pretty much flat and pretty much fixed. But this, the ultimate purpose here is, you can use these kind of plots also. You can customize it based on your need, based on the message that you would like to convey. The more beautiful plot is, try to convey each and everything. Your x-axis should be pretty much clear, y-axis should be clear, your regions should be clear, your color coding should be clear, and any number that you would like to put, this should be on the plot, but those should not be overlapped. Your message, each and every message that you would like to convey should be delivered from this plot. So make sure, play with it, try as many as plots you can. Try the all kind of plots and visualization plots on different type of datasets. At last, there is another library apart from the matplotlib and seaborn, and that library is plotly. And this library provide the users the flexibility to create the interactive plot. So interactive plot, again, you are using expressing like import plotly, express as a px, use px scattered for watch hours and monthly fee. You can change it whatever you want between x and y axis. Color using subscription type, size using average watch time per day. You are making the dot plot sizes also. And then hover data you are doing by the reason and churn rate. And title is interactive scattered watch hours versus monthly fee. You can run this. When you get this kind of plot, you are getting the watch hours on the x-axis, monthly fee on the y-axis, and the subscription type is based on the color, and the size of these nodes is based on the average watch hours. If the watch hours is higher, the node size will be bigger. Watch hours is lower, node size will be smaller. So here in this plot, the beauty is you can go to any data point. You are interested in this data point, you can see what what particular information about this data: watch hours, monthly fee, average watch time, region, churn rate, subscription type. Every information that you want, you can see about this data. So this plot is interactive plot. These plots help you to review each and data points. These kind of plots can be very very helpful from the reading purpose, from the descriptive purpose, from exploratory purpose, and even for inspecting each and every data point. Like, what if there are some outliers here that I would like to quickly view, not only on this plot but in the box plot or in any other plot. I can see the outlier and make a decision whether this outlier I would like to consider in the analysis, whether I would like to correct it, whether I would like to scale it, or I will remove it from the downstream analysis. So I think this is all about the visualization. If you know these three basics, first, whenever you will get a data set, how long it is doesn't matter. You are getting like 100,000 instances or rows, thousand of columns. First, decide, check the df info, check the describe function, how many categorical, how many numerical features you have, how many missing values you have. Make the decision whether you want to clean the data, you want to fill the missing values. Then take the decision that you would like to explore a variable at a time. Univariate analysis we discussed. Take the decision whether you would like to find the association between two variables at a time, or you would like to explore the multivariate analysis. Do it, find out the association, make the plots, convey the message from the data that you would like to do. And that comes with the question. When you start working on the data set, first your questions should be defined. When you're getting this Netflix churn rate data set, your questions should be in your mind. What kind of questions you are going to explore? Are you expecting any association between the churn rate and the age? Are you expecting any association between churn rate and the different regions or the subscription type? So those questions you can define. Then you will get an idea of the different type of visualization strategies. And at the end, when you will plot, when you will report those plots, your questions, your objectives will be carefully answered to the audience who are interested in. I hope you liked this session. I expect from you guys to practice each and everything that we discussed. Whether you would like to practice it on the same dataset, Netflix dataset, use it on this. If you would like to download another dataset, go to the Kaggle, download any dataset of your interest, depending upon if you are interested in a particular domain. If you want sales data, marketing data, lot of datasets are available on Kaggle. Download those datasets, inspect the variables carefully, make the visualization plots, practice it as much as possible. Try to understand the basics of each and every type of plot, what information they are giving. And I hope you enjoyed this session. See you in the next one very soon in module 5.7. Thank you so much. Hello and welcome to the mini modules. And the first mini module for us is the NumPy Essentials. NumPy is a very, very important libraries for doing all the mathematics, all the data imputation, data calculations in the Python. So this is a module which I created to learn a little bit more about the NumPys, because in all the tutorials that we are learning, in all the Python modules that we are learning, we are seeing some at the other places we are using NumPy. Okay, so here it's very very important for you to learn or understand the NumPy arrays, which are most generally faster than the lists, how you can perform the vectorized operations, how we can use NumPy for doing indexing, for slicing, reshaping, and filtering the data frames or the data. And even NumPy can be used for the broadcasting as well as the basic statistics that we do in Python. Okay, so now the question is, in general, now the question is why NumPy? So NumPy is a numerical Python in short, if I will say, okay, which is a foundation for all data libraries, which can be Pandas, SciPy, etc. Okay, so here sometimes we use lists which are flexible, but in NumPy, when we define the arrays, which are faster and those are more memory efficient. Okay, so NumPys provide us the defined arrays, which can be very very memory efficient and the faster as compared to the list that we use generally in the Python mathematical operation or for the calculations. This is perfect library for the numerical operation, for the matrix math and vectorization. In this, like, you need to import numpys as np, that we have done in many of the modules. If you don't have it installed, please install it using pip install numpy. Very simple. Okay, we'll simply see the code demonstration one by one. We'll learn about this library, and then we'll go and we'll see the code demonstration. Okay, so here I'm writing, let's say, mini module NumPy, in which, as I have already shown, first you need to do the import numpy as a np. Then this is a Python list, like this we already provide 1 2 3 4 5. You provide the Python list. Here in numpy you simply provide np dot array, the same kind of list you are providing here. You can print it, you can do any kind of function that you want. Like here for the speed comparison, you can try print np array multiplies by 2, and you can even try print np, and this is very simple operation, so you might not see the difference specifically in the speed, but you can try these two things. Okay, so like np array multiplies by 2 and np list multiplies by 2. By doing this, obviously you will get the answer. You will get the answer that is very simple. You are just either passing the list or you are passing the arrays. What you are doing, you are just doing the speed comparison by doing the multiplication of the two. Okay, so those things you can do. You understand the operations that you want to do. You want to be flexible with your list, you want to be fast with your list operations or numerical operations. So in that case you should start using the numpys. Now in numpys you can create and inspect the arrays also. Like you can define np array 10 20 and 30. You can define np array. This is array like a matrix, confusion matrix that we were seeing. You can check the dimensions, shape and size in these kind of things. I will give you the quick demo of other things, but before that let's see this, how these arrays looks like. So if you'll do the array of np array 1 10 20, so in this dimension is already 1, in b dimension is 2 by 3, so we have 2 rows and 3 columns. So you can define the arrays like this also, like in form of confusion matrix, in form of complex matrix. You can define that, and you can get the total size also. Size of this array is always 3, but size of this array which you are defining is 6. You can check most other things also, like quick demos for the np zeros, np ones, np arrange, np line space. Those kind of things you can try and test it. Let's say for example you are generating the array of zeros only. Okay, what you will get in zero? You will get multiple metrics for zero values. Here you will get for the one value. What you will get here for np arrange? So you can quickly check these things. For zero, what you are getting? 0 0. Okay, for one np1's array you will get 1. For the arrange x, in which you are doing the np arrange from 0 to 10 by the space of 2. So what you will get is 0 2 4 6 and 8. So you are providing the list which is from starting from 0 ending at 2 at the interval of 2. So that's how you can create, manipulate, change any of the list, any of the array by using this function. Now third is array operations. So in array operation you can do n number of things. You have one array called x, you have one array called y. You can do the addition, you can do the multiplication, you can do the dot products. So just you can quickly check. You have array defined in one variable, you have array defined in another variable. Just try these functions and see how it looks like. So when we are doing the addition, definitely we are getting 5 7 and 9. If we are doing the multiplication, we are getting 4 10 and 18. And if we are doing the dot product, then we are getting 32. So you need to just define your mathematical operation that you would like to perform, initialize your arrays, and then perform those operation on the initialized array. So this is very simple function which is like most useful. Now apart from this, what you can do, you can do indexing, slicing and filtering. This is very important. So let's say you are getting numbers. So you did np arrange 10, so you are generating 10 random numbers. For this, what you are doing, print original nums. First you are printing all the original numbers, then you are doing slicing. You are getting from 2 to 7. So from 2 to 7, like on in the original number you are getting 0 1 2. So 2 3 4 5 6, these numbers you will get. You can change this number as much as you want. I will print it at the moment and will show it to you. Okay, so this is 2 3 4 5 7. Then you are saying print every other element. So you can define nums semicolon 2. So in this you are saying that print every other number just after the interval of 2. So you are printing 0 2 4 6 8 because you have number till 9. And then you can do the filtering also. You can do print greater than 5. Only print the numbers which are greater than 5. So which is 6 7 8 9 0. You can do anything that you want. Print the number which is lesser than 5. You can do print the numbers which are the operator of the 3. So you will get 0 3 6 9. You can do this, change this operation from 1 to 7. You can check this, what you will do get from, if you will do from 1 to 8, you will get 1 2 3 4 5 6 7. So these operations actually, this function makes these kind of operations super easy, super consistent, and super memory efficient. Right now we are working with very small data that we are just providing, but when you will work with the larger data set, when you will work with the larger tables, larger data frames, then you will see the power of this function. This is extremely important, extremely useful. Then there is a broadcasting. In the broadcasting, what you are seeing, you are already defining a function np.array. You have defined the function of 1 2 3 and 4 5 6, in which you are just doing the scalar broadcast by adding 10. By adding 10, what you will get is, instead of 1, you are adding 10 to each and every element of this array. So you'll get 11, 12, 13, you'll get 14, 15, 16. Very simple. Just give it a try. Then there are stats with NumPy. So we have already the Netflix churn numeric data, customer churn data, which we have already downloaded. I have shown it in the multiple modules in the past, I think in the pre-processing module and in the advanced data analytics module. I hope this dataset is already downloaded with you. If not, go to the Kaggle, download it, or use Kaggle Hub library in Python and download it. And in this data, I'm just showing you simple, very simple example. You can just load the dataset like this. You can check how the data looks like. Let me remove this at the moment just to show it to you. Come and chat, remove this, how the data look like. So you can do data info that we have done in the past also. So you will get the data, you will get all the columns, and from all the columns you will see the integer, what columns are integer, to explore with the NumPy, because the categorical, the mathematical operation you will do only in the numerical columns. So numerical columns are the age, watch hours, and average watch time. You can simply get the nums, so by using the NumPys. So by doing this, let me remove this data frame just to avoid the confusion. What you will get is mean age you are getting, maximum watch time you're getting, and you're getting the correlation matrix between age, watch hour, and average watch time. So this is the correlation matrix you are seeing. What is the correlation between the age, watch hours, and the average watch time per day? Is there any positive or negative association? Those things can you can easily learn, but this is just a demonstration that the mathematical operation, the numerical operation that you can do are unlimited here. Just try and explore NumPy as much as you can. This is a very simple function. Take the data set that you want to load here and start practicing each and everything that we discussed, including filtering, slicing, manipulation, time series, doing the correlation, doing simple stats, doing simple maths. Try doing it, do practice as much as possible, and then we will try to learn the another section, which is pandas, in the next mini module. So here you can just take the key takeaway is the NumPy is a base layer for all data science in the Python. It can handle array slicing, broadcasting, and vectorization. We have already seen. Use it before underneath of pandas when performance matters the most for you. So I hope you will practice this module, and I will see you in the next mini module in which we will discuss the pandas in detail. Thank you.